update. It should update our page at any time soon, and it's already live. Implementing a database in Racket. That's exactly what we're doing, but let's be a little bit more. Implementing constraints in our database in Racket.
Uh, by the way, before we started, I just saw the weirdest, most random thing. Um,
Be careful what you're about
apparently,
to say, though.
no, it's about an anime.
Okay, go.
Apparently, there will be an anime called Isekai Suicide Squad, and it's by Warner Brothers, so it's actually official.
Yeah, I heard of that.
And I haven't actually looked at the trailer or anything, but it just sounds like the most random thing ever. Like, just why?
Why? I understand that sentiment. I do understand that. Anyway, let's start by by approving your PR because probably it is indeed correct. As I saw it. Anyway. So the first things first, I do think that the macro that you wrote is like field in a function. And then you grab the first and you grab the second and then you use the first and the second and validates.
Yeah, basically, you can think of it as a function, except you have to annotate the types of the parameters, kind of. And I did that because otherwise there would be a lot of repetition. And I do mean a lot of that. You see, I use that macro like in basically every struct.
No, every
So
struct is
yeah.
using this. I have another question. In the guard, do you have to return all the fields in the values thing?
You have actually, because that's the thing about guards. They are not just for validation, they are also for normalizing the inputs to the struct. Like,
Yeah,
remember
yeah,
I
you
showed
told
you
me.
the
You told
example
me.
with
Yeah.
fractions, yeah? So you do have to return the values like that.
Okay.
Uh,
So later we're
it's not
gonna.
mandatory. You can do arbitrary pre-processing of those two values. It's just we are not doing that in this case, which is why I left the option open in the macro.
Okay, but so you basically do your validations here and then you return it. I noticed that you remove the type tags as symbols and you transform them to strings. Why?
Because when doing these checks, I actually caught a type error. There are two places where we were passing different types to the type, ironically. So, like in one place, it was receiving a string as the name, and in another place, it was receiving a symbol. And I had to choose one or the other. I went with symbol because I don't know, it made more sense to me.
Wait, you went
But
with a symbol? I think that you went with a string, no?
no, I went with the symbol.
You removed
See, in the
the
check guard, name is the check for the name is symbol question mark. You see?
symbol question. Oh, here. Wait, I am
Yeah.
confused. Symbols in Racket. Yeah, there is a quote. What happened?
Oh, you mean the case there?
Yeah.
The case clauses are implicitly quoted already,
Ah, okay, I didn't know that. Okay, so
which
you
is
also
why
did. Go,
which
sorry.
is why actually you had to do the least quote thing before, since you were doing a quote when it was already quoted. I
Oh,
just
that
removed
explains a
that.
lot of things.
Yeah, I just removed that because it was not actually necessary. The minor simplification there.
Yeah, here you did a pipe. No, not a pipe. This is not a pipe. This is a thread. Wrong language. Wrong language. Uh, okay, that works. Is this a prelude function?
It is actually.
Weird. Weird.
Yeah, the closure equivalent is called inc for increment, but in Racket it's called add one.
Okay. Then you have the guards, a bunch of guards. That's okay. Yeah, the nice thing about it is that the same pieces that we did the contracts is the ones that you can use it here. That's really nice. That's really nice.
Yes.
Another guard there. Here we are basically requiring a Racket syntax, and now this is the piece of code that forbid me to approve this.
Yeah,
The
I
other
guess.
parts were very fine. Like they were, okay, that makes sense.
Let me guess. This looks like magic to you.
I wouldn't say magic, but I have a few questions.
Sure, go ahead.
Okay, so as far as I remember, in order to use the syntax subset, I'm not gonna use subset as a term. I'm gonna use like the quirky the quirky syntax world of Racket. You need to use this pattern matching thing.
Yes.
Yeah. So here we have args and here we have breadths and here we have the rest of it. Uh, why do we need the rest of it though? How are you
Because
calling this? Oh,
this
you're
is gonna
calling it
become
like
a
this. Okay, so this is inside the check guard actually.
yeah, this is going to become a lambda eventually. Lambdas have bodies, so this needs a body as well.
Yeah, but for me it would make a little bit more sense if the check guard only received this and didn't include the values. It's quite a
But
weird
that's the thing.
choice.
At some point, we may want to do like normalization of the inputs to a struct, right?
Mhm.
Like as I said with the fraction example,
Mhm.
we may want to do that actually for serialization purposes in some cases,
Okay, but why
right?
is
Of course,
doing it like this allow us to do that?
because we can write the body of the lambda however we like. If we didn't do that, we would be restricted to simply validating the inputs, which is a fine use case. Then we wouldn't be able to do normalization after, you see?
No, wait, I'm confused. In my understanding, maybe it's begin, right? Begin, begin, yeah, something like that. Yeah, begin, definitely begin. We could just open a begin here, do the check, and then do the rest of it.
No, you see, checked guard is actually syntax sugar for a lambda
No,
with a
no, 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 no.
particular
I
form.
understand that. I understand that the
Okay.
check guard is grabbing both parts. I'm gonna call them parts. So these are the parts of the checks, and this is the rest of what comes after the checks. After the of the list? No, this is a oh fuck. In Racket, what are the brackets? This is not list.
They're the same as they're the same as parentheses actually.
Okay, so they are
In Rack,
list.
yeah, in Racket there's no difference between parentheses, square brackets, and curly braces. You can just use them to emphasize different
Yeah,
parts
yeah,
of the
yeah. It's
code.
just styling.
Yeah, it's just
Yeah.
styling.
Anyway, but my
I
question is,
personally,
go
yeah,
on.
sure, go ahead.
No, no, no. You
No,
personally?
I personally like to use square brackets in situations where I'm treating a list as data, or in a situation where I'm binding names, which usually you have a list of bindings, in which case you're treating the list as data anyways, a list of names in this case. So they boil down to basically the same. And I picked that up from my time working with Clojure, because Clojure uses
Yeah, yeah, yeah.
vectors,
No, I
which,
noticed that this probably has some influence. But that's not my problem. Well, I don't have a problem. I'm just making a question. After we have this list of things, we have this other, that we have the body. What I'm saying
yes.
is that I don't quite follow what you're saying about what is the benefit of having the body included in the macro. Why the macro shouldn't just be this and then dot dot dot.
Oh, because if I did a dot 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 in front of the bindings, I would actually be expecting an arbitrary number of bindings,
Okay, actually
which
remove the
is
dot 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 then. Just the why not just this? That's the question.
because then I would have to inject constructed body into the lambda, which would probably just be values args dot dot dot, which works. It would just return the arguments as they are. But
Yeah.
then we are locking ourselves out of the possibility of normalizing the values before passing them to the constructor of the struct.
My understanding, and maybe I am misunderstanding, is that if you do, let's suppose that the check guard was just this expecting this guy, and then there was an extra parenthesis at the end of line 126. What would prevent us to put this in a begin and do the normalization afterwards and return that in a guard?
You would have actually to take the guard and call it on the parameters. It would be syntactically awkward because the check guard actually, when you evaluate it, it returns a function.
Yeah. You would have to call this. I understand that. You would have to call this.
I mean, you could do that, but then the error reporting could become wrong
Oh, that's a good argument. That's a very good argument.
because if you look at what I do to when I rate the argument error, you see that n down there. That's the argument's position.
Yeah,
I took some efforts to make sure that the n actually matches the order of the arguments of the lambda that you construct.
that's very nice.
So if you just called the checked guards inside of a function, you could pass the arguments in arbitrary order, right? And they could very well be correct. They could match up with the order you constructed the checked guards with, but they wouldn't actually match with the alter function that's calling the check guard. So that would make for a worse developer experience.
Wait. I think I got the first part. What wouldn't match with what?
So like in this function we're looking at right now, if there was a mistake in the row ID, for instance, it would report that there was a problem with the second argument, right?
Mm-hmm.
Because that's the position it appears in.
Yeah.
We could construct an example of a function that takes the arguments ABC and calls check guards, but passes them to check guard as CBA. And if there was a mistake in C, it would report that as a mistake in the first argument, which is wrong.
Wait. I have a check guard, and instead of using this order ABC, I'm using CBA, and it would report a
Which
problem
is,
in C.
yeah, the important part is that the order of the arguments to the check guard, they can be different from the order of the arguments of the lambda that calls check guard.
I don't know if I understand that. For me, one always follows the other. I don't quite see how they
They
can
they
diverge.
do in the macro I built, I wrote, they could diverge if we did the way you were suggesting, where where I call the check guard. I make the check guard without the body and call it inside of a lambda, which is your suggestion, as I understand it.
No, but yeah, still with that suggestion. I think I also said that. That was is what I was suggesting effectively.
Yeah,
Uh,
like I'm going to write an example in the chat. One
yeah,
moment.
maybe
That
that helps
should
because for me,
know what I mean.
this order here will always follow the order down here.
Yeah. So if we do this, then act, then CBA. Yeah, I wrote it.
Okay, so
And
you have a wrong order. You have a wrong order, and then there's an ABC, and then you're calling check guard with CBA, and then oh wait, the order
and
that you're talking about is the order of the arguments after the check guard.
no, I mean the
The
if I
CBA,
make check,
the latter CBAs, the last ones.
yeah, you see, they are being checked correctly. It's just they are being checked in a different order from the alter function, right? You would expect any error to happen if they occurred to be reported in terms of the arguments of the outer function. which they wouldn't be because in the outer function C is the third argument, but it's the first argument to the checked guard, so that would be misleading.
Oh, wait. So in that case, but we don't have that case here though. That we don't have wrong order ABC. We don't have the define, right?
We don't have it because that's how the macro was constructed. It was constructed to make it impossible to make that mistake.
I really don't see how my suggestion would have this problem. Let me try to explain. So the macro would be exactly the same thing, right? The macro would be exactly the same thing.
I
The only
mean,
difference is that we wouldn't have this part within it, and then the only thing that we would need to be careful, which is I think it's I thought was your argument. I thought it was your argument, is that you could have ABC down here, right? You
I
can have
mean,
ABC down
uh,
there, and then there's
I mean, if
CBA
you want,
in there.
yeah, I mean, if you want to be a bit more specific, now that you mentioned it, we could, I mean, I could make a syntactic sugar where if the body is empty, we just return the arguments, and that would basically follow your suggestion without falling into that pitfall, I guess.
No, but there's the pitfall that I just said. The pitfall of like, you have to make sure, because in the way that you did it, you actually, like you said, you made it impossible to these things to get out of order. They will always be following the same order. But I'm not concerned about this order, because this order doesn't exist here. I am concerned about this order and this order, because you need to pay attention of like, oh, if in the check guard I put C in the first position, I have to remember to put C in the first position when doing an application of the function, right? Because this would be a function, a lambda.
Yes.
So
Yes.
I have to pay attention to like C here, B here, B here, A here. And that is something that your solution doesn't, you don't have to think about it because the whatever order you put it is exactly the same order is going to be applied later. So that's
Yeah.
actually a good argument to maintain this version.
But yeah, about the like omitting the body, like if the body is empty, we could just inject a values to make it a bit more user friendly, I guess. That's an idea I had based on your suggestion.
No, but I'm very okay with the current implementation. Very okay. I just want to understand it. So let's start by the let. I noticed that after the pattern matching, we have an empty let, right? We have an empty
Yes.
let. And then we have something called define with syntax. And then apparently this is where the n is born.
Yeah. So about the empty let, I didn't want to put it there. Apparently, the that's an expression context, and in an expression context, you can't have a define in you can't have a
Loosely.
define loosely in an exception context. It's actually a syntactic error. So I
Weird.
made the let to circumvent that. And the reason the binding is not inside the let is because I don't like the indentation that comes with that. You will notice.
Sure, buddy, sure.
Yeah, no, because then you would have a let, and then after that, on the same line, you would have a name or whatever you're defining locally, right? And then only after that do you have an expression providing the definition of the name, which is way to the right compared to the actual codes that will use the name. So I prefer internal defines. I think they are easier to read, in my opinion.
Oh no, I also prefer internal defines. I use them in Rust, I use them in Racket, I use them in Clojure, I use them everywhere.
Yeah. So the define with syntax is a helper macro from one of the modules I imported for syntax.
Sure.
Um, Basically, it creates a syntactic binding similar to the one in the pattern above, except you can compute the expression that you are binding to the syntax, which is what I do there. I start with the list of arguments from the inputs pattern, I convert it. I use it as the lexical context for the resulting syntax
Wait, I
piece.
don't think I followed what this helper does. What is it doing again?
You can think of it as basically a define for syntax. The same way you're binding syntax in the pattern above, right? The args, the preds, and the body.
Yeah, but
I'm
what
doing the
is
same thing.
this?
It's a pattern. It's a syntactic pattern, the same kind you use in syntax case.
The same kind you would in a syntax case. Hmm. Let me take a look. This matches the syntax, does a pattern matching, okay, syntax result of an STX expression against pattern, and creates pattern variable definitions for the pair of variables of pattern. Hmm. Go on.
Yeah, so I define that pattern, the n dot dot dot. I use the arguments as the lexical context, so like for source line information and stuff,
Mm-hmm.
and also for the available bindings, which in this case doesn't matter too much, but I prefer to be cautious. And
Uh-huh.
then the actual syntax that we build, we start with the arguments list. We convert it from syntax to a list.
Sure.
We just count the number of elements and we do a range, which it's like the range enclosure. Like a range of n is all the natural numbers from 0 up to, but not including n. So 0, a range of 2 would return the list 0, 1, for instance.
But so then n is a list after all of this.
Yeah, so I construct that list, which is a list from 0 to however many arguments the
Yeah.
function will get.
Mm-hmm. Mm-hmm.
And then I bind that with, then I turn it into syntax and I bind it with the pattern and dot dot dots, which allows me to access each integer in that list individually in the pattern below, which is what I do.
Wait, what? So this is creating a pattern, and then you are mapping the list of 0 to n minus 1 numbers, and this is basically giving you at each, how do you call this, at each iteration?
At each position, I know I have the index of that position, which is used to raise an argument error so we can tell which positional arguments actually raised the error.
Wow, this is really hard to read. Well, not because of the whole extra layers of abstractions on top of the data code as data. The way that they did it is completely not intuitive to me, man.
You can think of it roughly as just a list of 0 to n minus 1, and I'm interested in each number as opposed to the entire list.
No, I understand that, but there's nothing on the screen that tells me that this number is varying according to something.
There is actually, it's the dot dot dot.
Where? Which line?
Um, in the line 78, the one after the parentheses.
This?
Yes.
What the heck this is doing?
It's basically saying there are some variables inside of this sub expression which were bound in a dot 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 context, which means they are actually like REST parameters. You can't use them on their own because that's a syntactic error. But what you can do is put a dot 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 after the form to basically say, okay, for each n in this case, I'm going to make a variation of this expression and splice it
No, but
into this context.
that's exactly the thing. Looking at these three dots, I can't in a million years see that for each n, the beginning of your sentence. How are you reading that?
And now you see why I don't like scheme macros.
No, this has nothing to do with the abstractions. This has to do how they connected one to the other.
No, but you see, if this was actually a common Lisp or closure style macro, it would be explicit. It would be like a map in this case, probably.
No, but you can do the same thing. Like you can still do the pattern matching. You can still define a pattern. The only thing that I'm not getting, which I don't understand how this is related to the scheme macros, is what's up with the dot dot dots, boys?
That's where you do an expansion of the previous pattern. So for instance, that args dot 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 is actually whatever, however many arguments were bound in the pattern above.
Wait, repeat.
The dot 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 in the return pattern, which is that lambda you were looking at, it means the pattern before the dot dot dot. Yeah, that's actually multiple patterns, and the number and relative ordering of them is based on the bindings
Why not
above. So
write that
like,
down? Just put previous here. Prev, whatever. This has nothing to do with scheme macros. This has to do with bad design choices.
but that's how scheme macros work, man.
No, but you
They
can
were
no.
made
But
to
like I
like
said,
mimic
you can do the same thing. You can still have all of this, not Marinho. But why the dot dot dot? Like this is
because they are
exactly.
made because they are made to mimic how you write mathematical expressions with variable numbers of
Really?
like yes.
Can you give me the Wikipedia page of that?
Uh, you know how in some mathematical contexts you write like a of one, a of one plus one, a of one plus two, dot dot dot, a of one plus x or
Yeah, this
something like
has
that.
nothing to do with pick the previous pattern one by one. What you just said has nothing to do with this.
No, it's basically taking that same idea, but instead of the dot dot dots being in the middle of the sequence, it's after the sequence because of the syntactic constraints of working in a Lisp, I guess.
I'm sorry, I can't understand the correlation between the dot 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 in math and whatever this is doing. Maybe I am capable of seeing the correlation, but for me it doesn't make any sense that parallel. But God,
Uh,
like, what a bad decision to use this to indicate that. Okay.
I can link you to a paper slash video that kind of explains that, but it would take a bit long, and I'm not sure if I'm up to the task of like transmitting that idea because my powers of communication
No,
are
that's
not
fine. I'm not
great.
blaming you. I'm not blaming you. Maybe I do believe it's my problem. I am the dumb one here. And again, I'm completely fine with the idea of having a very methodic way of doing macros instead of just using a bunch of tokens. I do think that has some potential because then you can differentiate things. You have more control over things, more finer control. What I don't understand is decisions like this. That's what I don't understand. Um,
Yeah. So
anyway,
now you see why I don't like scheme macros. It's mainly because of the dot 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 thing, actually. It's the main departure from how traditional Lisp macros are written, is that.
yeah, the dot dot dot. I'm not a fan. That's for sure. I'm not a fan of the dot dot dot. Well, anyway, so whatever you're doing here, whatever magic is happening with the dot 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 is grabbing every single pattern that you're grabbing from here, which is a list, and for every single n, you are basically outputting, like throwing these exact lambda
Not,
in its place.
yeah, not, it's not the lambda, it's just the unless expression, actually.
Not the lambda. What you said?
That dot 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 is just for the unless expression, it's not for the entire lambda. The lambda is the top
Which
level
dot dot
thing,
dot? This one or this one?
the one on the right.
The one on the right. So this is because of the unless.
Yes. You see, there are three variables inside of the unless that were defined in a dot 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 context: the preds, the args, and the n.
The args, the preds, and the n.
Yeah. See, on line 72, you have unless preds args.
Yeah,
There's no dot 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 there, right?
yeah.
That means we have to pick one. But which one do you pick? Well, the dot 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 after the unless says everyone actually.
Uh, wait. Raise argumentative name with output to string. Then there's another lambda in here. Write spreads. Are these spreads these spreads? I guess not.
It is actually.
Weird. Why do you need to
And it's
quote it?
actually just because I want to print out whatever source code
Oh,
returned
okay,
instead
that
of,
makes sense. That makes sense.
yeah.
Um, yeah, aside from the dot dot dots, I feel comfortable enough in order to approve it.
Okay.
Like I don't understand. We are complaining about naming for centuries, and people are using dot dot dot. Like like dudes, come on, come on, you can do better. You can definitely do better.
That's basically equivalent to the unquote splicing, except the notation is bad. I don't think using postfix notation for this particular case is doing any favors. And the way this is composed is actually not particularly intuitive from a execution perspective. So yeah, I agree
Eh,
that it's bad.
eh.
Which, as I said, is why I don't like scheme macros.
But like I told you, I'm fine with the idea. I just have problems with the implementation details for some random reason. Uh, okay, we're gonna do AST today, which I need to remind myself to change my mode for indentation at some point. Sad,
Yeah.
very very sad. Okay, so we're gonna work on table today.
Yeah.
Let's
Speaking of
grab
yeah,
the thing that you wrote
yeah,
and
speaking of
let's put it
indentation,
here. Go on.
I also need to configure my editor to like do the indentation in the style I like for Racket because I have to fight it a little bit to indent things the way I prefer, which is not ideal. And I haven't looked into how to configure it because I was just using the Racket mode that comes from um, from a plugin I installed, and I didn't mess with it myself. So yeah,
That makes sense. Okay, so we have serialized constraints. So what did I just said? I said 2 bytes for the amount. You're already raising a thing. So what are you raising, my friend? So you're checking if the count is less than whatever this is in hexa,
it's just 2 bytes, the highest 2 bytes value, unsigned.
but you're checking. Unless. Oh, I got trolled. Okay. Uh, okay, that makes sense.
Yeah.
So okay, now it's time. So let's think about it. So let's. Well, you're using defines, man. You're using defines. Well, for this case, I guess it makes sense. But I'm really fan of let's. Uh,
In Scheme, a define inside of the body of a function is basically sugar for let's rack actually.
I believe you. Integer, integer bytes. Right, we have integer bytes, which I already forgot. I kind of already forgot the interface for that. So let's grab Racket docs. There should be a thing. Um, okay, so it is the number, then the size. Of the.
Signed would be false in this case, I
No, it
think,
would be
because it's a natural
false.
number, right?
Um, no wait, it needs to be false. Yes, it needs to be false. But that's not what I want actually. I want some sort of granular control to tell how many bytes.
It's the second argument, the size n.
Wait, why are we wasting? I guess I assume that this can be really big because you can have multiple rows. Well, I guess it's fine. Um, So let's do it then. So we're gonna put count. Count seems to be a thing.
It's the length of the
Constraints
constraint.
count.
You have to rename it in the unless as well.
That's true. That's true. Forgot about that. Forgot about that. I should have this
Yeah.
here.
So the size would be 2, I guess, and
Yeah, the
then
size
false.
would be true. That's actually very.
Uh,
It would be kind of
false.
nice.
It's false, not
uh,
true,
It would be
because
kind of
it's
nice
whether
to
it's
have some
signed.
sort of control to like, if I change this number here, something should scream on the deserialization side, and that would be kind of cool. But it also sounds like a lot of work.
It does.
The best part is you just agree. It does sounds like a lot of work. Uh, Serialized constraint. And then we're going to call a function called serialize constraint, which will actually going to map it, right? We're gonna definitely map this. We're gonna map that passing
The constraint list.
the constraint list. Yes, the constraint list. After that, after that, um, um, after that, what should we do about that? Actually, what we need is a concat map. So how does Racket handles that? Do you know concat map
Uh,
from Haskell?
I think it's called
Join? That would work.
mapcat. Mapcat. If it exists, right? Which it doesn't.
Which doesn't, yeah.
uh,
Uh, oh man, every single time this happens. Where is my Hugo? Where is it? This happens with a frequency unbelievably high. Okay, but for now, later on we can find the syntax sugar. We're just gonna byte join this, which is okay because I do have it already. Bytes join, and it's gonna be that, and then we're gonna put there's hashtag here and there. Okay, that will definitely work. Then we're gonna unite these two things, and we're gonna do bytes append serialized count with serialized constraints. That seems okay. That seems really okay. Constraints. Yeah. Okay, now it's time. Now it's time to define the big boys. Serialize constraint. And you're gonna just receive a constraint here. So what should we do about that? Okay, so this is where the syntax stuff comes in, right?
yeah, right.
So
So
we're just gonna constraint size. You're gonna need that. And then here we're probably gonna need to transform it to some sort of syntax object and then do length on it. Am I right?
um, no, actually, the constraint size would be the byte length of the serialized thing, right? So it's something we would have to compute at the end, I think.
Wait, what? No. This is on the constraint level. So this is gonna be do for each individual constraint.
Yeah, no, but the first 2 bytes of the constraint is the length of the constraint in bytes, right?
No, it's the length of the total list of constraints in 2 bytes, including this one.
Uh, isn't that the constraints count, which is defined outside already? like we had decided the way we serialize it, there are 2 bytes telling me how many constraints there are in the file, right?
Yeah,
And then each constraint starts with 2 bytes telling you the length of the constraint, right?
which is what I want to calculate now.
You can't. You have to serialize it first so you know how many bytes there are, and then you count those bytes.
Oh, so there isn't a way to pick a piece of code that is treating as a data and getting the length of it. I need to serialize it
There,
first.
there is a way, but that would give you the wrong answer because a syntax object is basically a struct. It's kind of like a generalization of lists and symbols, but with source code, source line information, right?
Mm-hmm.
But that means if you turn it into plain data, what you get back is a list. And if you get the length of the list, that doesn't tell you anything about the length of the bytes that you need to serialize the list.
Oh, so when you serialize the list, the Racket, you basically are adding more data, and that would mismatch if I just count the bytes.
Yeah, like suppose you have a list of 3 elements and they are all the symbol A, right?
Sure.
The length of that list is 3. If you serialize that into bytes, it would take about, let's see, there would be a byte for the open paren, a byte for the close, that's 2, then 3 for each for the three
Yeah, yeah,
A's,
yeah, but
and
that's
then
what
2
I'm
more for
talking
the
about. That's what
spaces.
I'm talking about. Isn't there a way to pick a piece of code in Racket, treat it as data, and then it's gonna count all the parentheses and the spaces and all the tokens? I need to serialize
But
that
that's just,
first.
you're talking about the length of a blob of bytes that will follow that length, right?
Yeah.
Proper way to do that in a general way is to serialize it first and then you count the bytes afterwards. Because like suppose let's go back to the length 3 example. That would be something like I don't
Because we are talking
know,
about
8.
something like this, right? No, not that. Oh fuck, I forgot. Ah, too many lisps. Yeah. Yeah, so we are talking about this, right? So A. So this is a
Yeah, so
constraint,
if you turn
I
yeah, that
suppose.
would be a piece of yeah, that would be a piece of syntax that will evaluate to a lambda, which we are calling a constraint because that's what is going to be used for.
Yeah.
And if we turn that into plain data, it would turn into a list of 3 symbols, each of which is the symbol A. And if you serialize that, that would be 1, 2, 3, 4, 5, 6, 7 bytes.
Yeah.
But if you count the length of the list before serializing, it will tell you 3 because it's a list
No,
of
no, no,
three
no, no. But that's
symbols,
the thing.
right?
That's what I'm saying. I'm not saying. Let me make myself clear. I'm not saying for us to do this length constraint. I'm not saying that. What I was imagining was to be something along these lines, like, oh man, I don't know, data fixum. I don't know, some weird thing, some weird thing like that. We would transform this thing into something that allows us to get the proper byte information. But I didn't think that would be directly serializing it. I thought it would be some intermediary format, like the syntax stuff that we just explored in the PR. And then we will be able to get the information from that, and then we will transform it to bytes. But what you're telling me is that we shall transform it to bytes all the way, and then get the size.
Yes.
Yeah, yeah, that works.
Yes. So basically, the constraint will be a piece of syntax. We already established that. We have to turn it into plain data because, as I said, syntax is basically a struct, and it's you can't write that in and expect to be able to read it back because you would be losing some information there. So the function to do that is called syntax to datum.
I have a question though.
And
We need to get rid of the new lines. How are we gonna do that?
I'm pretty sure that the only way to have a literal new line with the way I'm thinking of doing that would be. Is there a way to actually do that? I don't know. No, what I mean is, you said we want to serialize the Racket code like as is, right?
No, we don't.
The most straight
We don't.
we don't.
Yeah, because if you do that, we're gonna add new lines, which are these.
You're thinking in terms of textual syntax, right?
Yeah.
That's the wrong level. That's the wrong level of abstraction, man.
Wait, so when you serialize a piece of data, code as data to syntax, it gets rid of the new line. It gets rid of the new lines.
Ah, Look, before this is even considered whether to be code or not, first, the way a Lisp works in general is first you parse the S expressions into a list of symbols, basically, right?
Yeah.
And then
Yeah.
you evaluate that.
Mhm.
The step that turns that into syntax inside of a scheme is already after the read, which means there's no text anymore. It's just lists of symbols.
Ah, okay. So that means, well, that means that we already lost the new lines. Okay, that's great.
Yeah,
Okay, so what's the function datum to what?
syntax to datum.
So let's read. So let's fucking read. Returns a datum by stripping the lexicon information, source location information, properties, and temper status from STX. Instead of pairs, immutable vectors, immutable boxes, immutable hash table values, and immutable prefab structures, syntax objects are recursively stripped. That makes sense. The stripping operation does not mutate. It creates new pairs, vectors, blah, as needed to strip lexicon source location strip recursively. That's quite cool. So how does that work? What is it transforming to though? It is transforming to any. How nice. What are we gonna do about that?
That's fine. We know it's going to be a list already, right?
No, it's gonna be a list of what? I have no idea actually.
Well, the first symbol will probably be lambda, then it will be probably followed by a parameter list, and then the body will be depending on whatever constraints were specified by the user.
Yeah, but I mean, we need to convert that to bytes, right?
There is a way to do that. That's very common in Lisp, and Racket is not different. And there's a function called write.
Hmm, it returns void.
That's because it's a side effecting operation, but we can put it inside of a we can pass it a port and make it output to a string that works. I guess it would be a byte string in this case, right?
Yeah, so probably lives like in here, I guess. Um, no, not that. So how do you create a port for a string? I don't remember doing that before. I only created ports for files. Ports for files.
It's there's an example of that in the util file actually with output to string, and ironically enough, or I guess not ironically, it's actually in the macro we just merged into master. In the code it spits out inside of the pattern.
This
Yes, it's
with
basically what you're
output to
gonna do.
string. Output to string. Hello? Wow, took a lot of time. So how does that work? So you pass a procedure. Oh, okay, that makes sense. And then you gain the port in the lambda. Okay, okay, I'm very satisfied with that. But I do believe we need to add stuff. Probably this
Yeah, no, we
bracket
don't.
port.
Bracket part, I guess.
Port. There isn't one.
Maybe not actually. Could. let me double check that. With outputs to
Maybe it's
string.
re-exported by one of these.
It's actually re-exported by Rackets. The Lang Racket already has it.
No, okay. So let's go back and let's do it. So this will be wrapped in a oh fuck with output to string with output to string. Nice. Which will provide
Yeah,
us a lambda with
often
an
zero arguments.
export.
Yeah,
True
no,
arguments.
no, zero arguments actually.
Zero. I'm
Yeah, the
confused now.
example there, the source code there is actually an equivalence. Like,
Oh, it is equivalent to, but now I'm even more confused. How do I receive the port?
it's not explicitly available to the lambda you pass. It's abstract away inside of the S. Yes, because you see the write procedure, you can optionally give it a port, but if you don't, it writes to the current output port, which
Ah,
is
I'm not a
what
fan of
the
that. I'm really not a fan of that.
is dynamic binding basically.
I would rather go with call here then. Uh, then we're gonna use write. Is that it?
Let's see. You have to pass the port as the second argument. Actually, it's backwards.
Wait, call with output port. No, call with output port doesn't requires anything aside from the lambda man.
No, no. The call to write, you're passing the port as the first argument. It has to be the second.
Ah, sorry. Weird. That's very weird. Why would they make such
Uh,
decision?
because
I would like to compose this and make like a partial applied right. Why would they ever do that?
I mean, you can. I'm pretty sure there's you can call curry to on write
No,
with
you can do that, but
the
what? Like, why? Why just don't put? What is the main benefit of putting the port on the second position there?
um. Well, I know of one benefit, but it's on the side of the implementer instead of the actual user of the procedure.
Not a fan. That's what I have to say. That's really what I have to say. So how does that work? So this is actually a string. So we are done. So I'm basically gonna call more parentheses because here we love parentheses,
you have
and we're
you
gonna
have
have
to
to
turn the
deserialize this.
string you have to turn the string into a byte string first, because
Yeah.
a string and a byte string are different things.
No, no, yeah, I know. I just have to remember how because it's been a while. Probably here actually. Where is the identifier?
It's string to bytes slash
Oh,
UTF-8, I
it's
think.
here. Yeah, exactly what you said. Here. Okay, that's gonna be cool. We're gonna see Racket code in the middle of the party of bytes, man. That's gonna be weird. Length, and then we're gonna put serialize constraint. Do I have to put any? Yes, I do. I do have to put. Okay, guys. So now what do we need to do? I think
You
that's it
just
actually.
you just have to join the size and the actual constraint, one after the
Yeah,
other.
but I
That's
just
it.
remember that this is a number still, so I need to do integer bytes, and after that we're gonna put true and false there. Okay, I got confused. Yes, yes, yes,
Uh,
yes. Okay, so and now here we're gonna do a bytes append, and then the size and the serialize constraint. Hmm? What do you think about it? What do you
That
think about it?
should work.
You know the
I
funny, you
don't.
know the best part? Do you want to know the best part?
What's the best part?
The best part is that if you only make the serialization, it's gonna break. So we are forced to do the reverse. We are forced to do the reverse. Which actually reminds me, I think we actually did the serialization of constraints, but we didn't put it here, which is rather important. So I'm gonna just do constraints. I mean, I'm gonna put value for the sake of being close to the other names. So this is gonna be serialize constraints, and then we're gonna do table constraints self.
Oh, that's the deserialize function, right?
Yes, I was put in the wrong place. Thank you for reminding me. It's here actually. It's just there. Okay. And I did,
Um,
yes. What I should have done is this. There, there. We can call here constraints. We have the self, and then the order here matters a lot. So let's think. What do we want to be first? I think I want this to be at the bottom.
I mean, the constraints list is the one that will probably vary the most in size out of the other possible things to put in a table.
Yeah.
And it's probably the one that can grow the largest, so it makes sense to put it at the end.
Cool. Okay, but like I said, now that we have this on, it's gonna break, which we can already just fix it. Um, I'm actually gonna do the reverse order this time, so I'm gonna just put constraints value, the serialize constraints. So good, so good. We don't need to pass the type descriptor. We only need to pass. Oh, we gotta do the math. I forgot. Oh, sorry. We really gotta do the math though.
Yeah.
Um, so the first row ID is 4 bytes. That makes sense. The field's value is.
There's a bit of a hack we can do. I
Ooh,
don't
this
think
is a
it's a good idea.
problem.
What is the problem?
This is a problem. We don't know the point of which we don't have fields anymore. Ooh, that's a huge deal, man. Because you see, this is assuming that the remaining bytes are all fields.
Oh, yeah, that's a problem.
That puts me to, just for the sake of being
What if
faster,
what if the constraints are at the beginning then?
I think it doesn't really matter if it goes first to row ID. It just really matters that the fields needs to be at last.
Okay.
Yeah, that's unfortunate, but it is what it is. Uh, it is what it is. So actually, actually. Ooh. Okay, this is getting even more interesting with more we do it. This realization is always the worst. It's incredible. We're gonna have to do a define here. Can we do a define values inside a let?
No.
Ah, fuck.
Which is why I like to use internal defines because you can just do that.
I think we're gonna have to. I don't have a choice. I'm gonna have to do your way. I'm gonna have to do that. This needs to be a define
Uh,
values. These needs to be defined values. And the first thing, I don't know what is the convention that we are using here. Okay, the first thing is the thing itself. So this is constraints value, and this is gonna be constraints length actually. And then we're gonna actually call this serialize blah 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 like that. So then
Uh,
this other thing here, this other define, uh, this other define will have
there's
to use the constraints length in order to do the math. In order to do the math.
there's an extra layer of parentheses in the row ID value definition.
Yes. Yes. Okay. Quite nice. And then here will be subbytes byte stream for to the end. Actually, it's for to the end. And that's it. I think that's it. And then that's gonna be it. We have a problem. What? Where is the
And it
problem?
should be constraints length plus 4, right? I guess.
That makes sense. That makes sense. Good catch. This is actually the parts where I usually. This is where the problem arises because you need to keep track of the math. If you get it wrong, it's gonna take a while to discover why. Where the heck is this closing, man? I'm very confused. There's an extra parenthesis? Yes, there is. Okay, so far so
Oh, it's
good.
because you got rid of the let that removes a layer of parentheses uh, in the
Okay,
body of the function.
so
Oh,
let's
yeah.
go. So this serialize constraints. This needs to receive a byte array, and we should add a comment. Remember, this needs to return two things. Okay, so what should I do? So the first thing is how many, right? So that's the first thing. So let's start with a let. How many? How many constraints? Um, how many constraints? And this should be subbytes byte array 0 2, and actually this should be a number, so this should be integer bytes to integer. So that's how it goes. uh,
By the way, this is something I noticed I haven't seen in the code yet. How are you dealing with endianness when serializing the things?
Handling with what?
Endianness, like the order of the bytes, whether they are from most to least significant or the other way
I
around.
have absolutely no idea. I'm using the vanilla thing. I have no
By
idea of the
default,
implementation details.
I'm pretty sure most of the integer serialization stuff in Racket uses the machine's native endianness, um, which is not something that we want actually, because it could be that you run this on an ARM machine and you serialize some bytes, and then you want to read that back in an Intel machine, and then you have a problem.
Okay, I gotta concede on that. That's definitely the case. That is definitely the case. But I don't think the first version of Rocket Tower will be multi-platform at all. If it runs on a Mac, I'm gonna be already satisfied, to be honest.
It should be, I think. You're not using anything platform specific uh, from the Racket library, so it should run on mm, whatever platform Racket supports, I would think.
Yeah. The sad part is that we have how many constraints. That means we can we I don't know how we're gonna do this a functional way though.
What? Do you want to know the total length like first?
No, we need to we know how many repetitions we're gonna do, but I don't know how we're gonna do that in an FP way. Because usually when you're doing a fold, you don't actually know how many times it's gonna fold. So now what?
Um,
Now what?
I mean, You can do a right fold, I guess.
A what?
Fold. I think it's called fold R.
Fold R. And what this has to do with how many things?
Um, you can pass in the number of constraints as part of the accumulator. Well, it's not a loop, so it's kind of wrong to call it an accumulator, but um, the value that gets passed in between the between each step of the fold, instead of just keeping track of the value we're parsing, which is a list of constraints, obviously, we should keep track of how many constraints there are. Um, and since it's a right fold, it's going to parse them from right to left, which means we just have to do a sub one at each step to like count down until the end.
I'm not following
And
exactly how we're gonna because we need to use the counter to stop. How are we gonna stop with a fold? And we can't start from the right, by the way, because the right has bytes for the fields. Remember, this byte array has the fields and the constraints.
no, but that's the thing. Like you start with, let's use four constraints as a running example, just so we have something concrete, right? So we have four constraints. So at the first step, we go, okay, did we reach the end? No, because four is not zero.
Sure.
So which means the next two bytes are the length of a constraint, which means in the next the recursive call, which will have to be evaluated first because it's a fold R, not a fold L, we will have to skip that many bytes, which we know because it's in the serialized data, the length of the constraint that we have to parse. And we also decrement the number of constraints we are parsing.
I still don't see how we're gonna make this stop, but I trust you. We already did this with spatula when me and
Yeah, and then
Nathan we were just
yeah,
saying
and
things and
then
Magenta didn't understand. Let's just type the code down, and then if I don't get it with the code in front of my eyes, then we can go to more brainstorming. Because if you already have an idea, maybe I am too tired, maybe I'm not thinking right. Um, then I think it would I think it's okay to trust you in this case. If you have certainty that it's gonna work. I really don't know how we're gonna stop the fold. But okay. Another thing that I noticed, we gotta do the defines. We have another define here. We need to deserialize a single constraint. Maybe that's actually gonna be a little easier. Uh, I'm without names. Uh, list.
just use byte array, man. It's a separate function from the other one.
Yeah,
Yeah.
I know, but well, usually I get confused with the same names in two different scopes.
Okay, that's fair.
Okay,
Um,
so
that's not actually very hard. You just have to parse the first two bytes, which would tell you the length of the byte string that you're actually interested in, right?
okay, so constraint size, which is wrong because we need this. So let's do it. So we're gonna do sub bytes, actually integer bytes, and then sub bytes byte array 002. So we know how many bytes we do have it. We're gonna use that probably, so I'm gonna put a star here. And then we're gonna have the constraint itself, right? The constraint itself. So how the heck are we gonna do that?
You
Probably it's gonna
know
involve
how
datum to syntax.
it will actually,
That makes
and
sense.
we will have to go back to that after we do the actual parsing. The actual parsing is very easy. You know how we used write to serialize the data?
We use yes.
Uh, there's another function called read that reads data.
That seems cool. So what the read needs? Let's take a
Just an input
look.
part, which is optional.
Which is optional. Interesting.
I'm pretty
But it
sure
needs
there's a
an
function.
in. Wait, but
I'm
how
pretty
does
sure
that
there's a
work?
function.
How is
I'm
the
pretty sure there's a.
optional, man?
If you don't give it an in, it reads from the current input part.
Oh, okay, that makes sense.
I'm pretty sure there's a way to turn a byte string into a part. It just, I just don't know it off the top of my head. I wonder if there's a read bytes actually. That would be easier.
No, there is a read bytes. There is a read bytes.
Oh, oh yeah, no, it doesn't do. No, I thought it was related to, but it doesn't. Okay.
Okay, so we're gonna use read anyway.
Yeah, we have to use read, and then I'm pretty sure there's a way to turn bytes into a port. As I said, I just
Bytes into a port? What does that mean?
there's a way to turn a, like you know how in some languages you can open you can take a string and basically make a port that outputs the bytes from that string. That's basically the idea. It's just
Okay.
oh, I think I found it actually.
Okay, while you were doing that, I'm just gonna do values because this is actually super important as well. Uh, there's some math, and then there's gonna be the constraint. So the math, let's think about the math. The math is
Oh,
gonna
how
do
appropriate.
2 plus constraint size. Did you find
Look
it?
how appropriate it is. I found it. I sent you a link. It's called Open Input Bytes.
Oh, I use
Um,
this. I use this.
and the example they give is actually of parsing source code, which is exactly what we're doing.
How nice, how nice. Thank you, thank you. That we of the of out of the 5 examples, one of them is the one that we are looking for. That is quite rare. So let's not take that for
Uh,
granted. So how does that work? So you pass the bytes now? Is that it?
yeah, sub bytes. You have to keep the first 2 bytes because that was an integer, right?
Constraint size.
Constraint size +2 actually, because of the 2 bytes we
Oh
skipped.
yeah, I always forget the shift, man. Thank you. Yeah, yeah, thank you. Okay, that's it. I think. I think
And
that's.
then the deadcom to syntax actually needs a second argument, which we can just use.
Let me actually not cheat. Let me take a look at what this is. Syntax. There. A bunch of English, as always. It
Um,
needs 2 things. You're right. It needs a context, whatever that is.
it's basically
Oh,
we
I
can
think
pass
you
false
mentioned,
as the
right?
context. Yeah, it's basically another syntax object that it uses as a reference point. Like, okay, I'm turning this value into a piece of syntax,
But this can be
which
false.
selects
What do we want to do?
apparently. I don't know exactly what semantics are if you pass false there. Let me just read it. Atom to syntax. There we go.
Blah.
Lexical context. Context. Oh, okay. It just has no context if we pass false. That works, I guess. We can just pass false for the time being. Eventually, we'll probably want to create a specific value for this. Um, for the sake of controlling which bindings are visible from the syntax, but let's not worry too much about that for now. Just for the time being, let's just use false, I guess.
Nice. I
It's
got
the
lost here. And then the result is going to be two things. So in each, both all this serialization functions, aside from the fields, and actually now this makes a lot of sense that the fields doesn't need to return two things because it's the last thing to be deserialized. So we don't need to know how many bytes it actually consumed because at the point that the fields are deserialized, we know that the entirety of the byte stream is already consumed. So that's why I did it differently.
I
Uh,
see.
but this is not the case because we are deserializing a piece of other information, other piece of information, which means that we need to return two things, which makes sense. Now we're gonna do the thing that you understand and I don't. So let's go. What should I put here? Folder?
Uh, I mean, I was thinking of folder, but it actually might be easier to just use a named let for this
A what?
because we a named let because we will have to flow.
Named let. What is that?
You know how in closure you have a loop expression?
What the fuck is this? 1 second.
That's not it. That's not it. It's actually just a special case of let.
Okay, continue your explanation in closure.
You know how in closure you have a loop expression where you say open parens loop,
Yeah.
then you pass a vector of bindings with initial values for the bindings, and then inside of the body of the loop you can call recur, and that basically goes back to the beginning and resets the binding, but it looks like a function call. Semantically, it's like a function call, so it's basically a functional loop essentially.
Oh,
Um,
that
a
sounds
named
cursed. I like it.
a named let is basically that, but in scheme, and it's nicer because since you are not using a special form recur, you're not actually restricted to doing tail calls. But that's not what we want. We actually do want the tail calls in this case because it's an actual loop, I guess.
Okay, so what's the syntax up for that? Teach me.
Let and then a symbol.
A symbol.
Yes, a
Wait, this is
symbol.
closure symbols. This.
No, no,
So
no. It doesn't have to be quoted because let is a piece of syntax. It's not a function. So
wait, symbol? That?
it doesn't. No, it can be any symbol. It's basically a loop label, I guess. You can think of it as a local function that you're defining in line and then calling
Okay, I'm
immediately.
gonna call it loop then.
That's fair. And then it needs some bindings with initialization for them, basically like a normal let. So
So how does that work?
just
So I'm gonna do this and then that, and then what I'm gonna put in here. Is
first
there
of all,
is
we
there is
definitely
there any
want.
example on that? Because I think I would like to see.
I
Ah,
think there's
here.
actually an
Is this what you're
example.
talking about?
Yes, it is.
So how does that work?
It's basically defining a function and calling it immediately with the initial bindings as the arguments.
Wow, that's really cursed indeed. Okay. Um, okay, so let's call it loop for now. So what are the things that we actually want this thing to loop upon? We want to loop
Um,
an
the number of
accumulator.
constraints, yeah, the number of constraints is definitely one of them. We need to a list to accumulate the results as well.
What is the first thing that you said?
The number of constraints, because we have to keep track of that.
Okay. How many? Uh-huh. What other things
And
we need? I never use
And
this. I'm very impressed.
I think that's it actually.
Okay, so now what do we do here? What do we do?
Well, if the number of constraints is zero, we just return the accumulator.
Okay, so if I always forget what should we use equal
Zero question mark.
zero question mark and
Not the number zero, the actual word zero.
if it's zero we just return the accumulator.
Yes.
Otherwise, otherwise um, we should the accumulator is a list, so I think it's going to do like append ACC.
Yeah, it's actually going to be a const, I think.
What does our accumulator need to have?
It needs to have the syntax values we are deserializing.
So why do we need the cons? I have no idea.
Um,
We don't need the cons to
because
save the true things here. I think you said that the cons because of this, right?
yeah, the const is actually the thing we're returning, like the what is it? The actual list of values, right? It's one of the returns we will
Yeah,
provide,
yeah, yeah.
I
But
guess.
actually, we need another thing here. Consumed bytes. Yeah, we do need that. Uh, which is actually wrong because we're gonna have to do. For now, I'm gonna put it at begin because for me it makes sense. Define values. Constraint size and constraint value. And that will happen on ooh, ooh. We need to man, this is not we made a mistake here. We did made a mistake. We need to remember to cut the byte array because then you're gonna just be keep rereading it. This function
Yeah.
doesn't
Uh,
know that. So this function always assumes that the beginning of this is always useful.
yeah.
I know we are recording, but I gotta get out for 2 minutes. One second.
Okay. Okay.
Okay, I'm back.
Welcome back.
I'm back. Sorry for that.
It happens.
Okay. Yeah, man. Being the only IT person on the house, it's hard.
It's harder. It's harder. Nobody understands.
Yeah. Yeah. Okay. But where was I? Oh, I was talking about that this function doesn't know. This function assumes that the beginning of the byte array is actually free to deserialize for its own constraint, which means that we need to cut the byte array that this guy is using. So I think we also shall use the stream. We also need that.
I I think you might be overthinking this a little bit.
Um, well, let's start with what makes sense, and then we can cut and optimize it. So what I'm gonna propose we can just deserialize the constraint. So we're gonna pass the string, and of course, I'm gonna call it string B. This is not gonna. This is a key keyword. So now we need to return the accumulator. We need to return the accumulator, but how does the documentation mutate stuff?
It doesn't. It's a functional binding. You have to call technically, you could use set. That's not how let loops are usually used.
Oh no, but we don't need that. We actually can do very non. We don't need to mutate that because we can just do uh, append acc, and then we're gonna call loop, and then we need to pass the things. So I'm assuming that the order maintains. Actually, now that I think about it, the accumulator is already there, so we don't need to append here. Uh, we don't need to append there. That makes sense, okay? So what we're gonna do? We're gonna do the first thing. So the first thing would be the accumulator, but the accumulator with extra stuff. Oh, that makes sense. So append acc constraint value. That makes sense. This is gonna be n minus one. This is gonna be plus consumed bytes and then constraint size. Nice, nice, nice. Then the last thing is the string. So we're gonna do subbytes, oops, ah, subbytes string b, and we need to jump constraint size. That should work. Does that make sense to you?
Let's see. String string B. That's not a thing, is it? Define values, constraint size, constraint value. You serialize it, and then you append. Um, by the way, append in a recursive loop like that is usually not a good idea.
I have no idea what you're talking about. I did this multiple times in the code.
That's because ACK is a list, right? Which is a linked list because it's a scheme we're working in. I mean, it's not strictly speaking a scheme because it's Racket, but it's based on a scheme, so it's close enough. Which means that actually append is performance-wise, it's not great. It's linear on the size of the left
I
argument.
understand that, but again, this is just a very rough draft version just to see if it makes sense as a proof of concept. And after we make it work, we can make it pretty and faster.
Okay, first of all, the accumulator, that's not gonna quite work, is it? Because the deserialized constraints also has to return the total bytes it consumes to the caller.
That's true. So we need the cons at this level.
No, you
Uh,
need the values there, actually.
oh, it is a values here. Sorry. Values. What is the first the size? So consume bytes and then the accumulator.
But then, let's see. Uh, Yeah, first of all, that begin there is not gonna quite work because um, it's in an expression context, which means you can't have a define inside of it, which means it has to be a let.
But how does that work? Because we need to grab two things from from calling this thing.
Yeah, remember how I did a let with no bindings and then immediately inside of it I have a define in that macro?
Oh, okay, that works. Ah, not a fan, but it works.
And then let's see, you were reducing the number of constraints, you're adding the value to the list, and then you're adding the consumed bytes to the constraint size, which is correct.
And then I'm slicing the byte stream.
And then you're slicing the byte stream. Um,
Oh, I'm removing the
no,
bytes that we just deserialized, basically. That's what I did.
no, I see now. That could work. Yeah, that will work, I think. Other than the fact that append in a loop like that is gross, but okay.
I don't see the problem with it because this is not like append on an append on an append because this is already
But it
something
is,
calculated. Wait, it
but
is?
it
So
is.
this is like a lazy language or something?
No, what I mean is that you're calling append on an append, right? The accumulator will keep
No,
growing.
no, I'm not calling an append on an append. This is not a recursive call. This, what I'm highlighting here. Like this isn't this. Append. This isn't that. You know what I mean?
Actually, append like that, nesting on the right, is not so bad. It's just you're adding things at the end of the list, right? That's your intention there, at least. I
No,
think
it doesn't matter the order actually.
it does matter
No, no, no. For
because this is
us
a
it
list.
doesn't matter. Maybe for performance it matters.
Well, first of all, you have to put a list around the constraint value, otherwise you're gonna break stuff.
Oh, is this one of those Lisps that I need to do that? Are you
No,
sure?
that's just a thing with append in general. Append means you have two lists, you append them together.
Really? So,
In closure, that's actually called concat, which is probably why you
so that's
know.
not what I want actually. I want kind of like Haskell cons. I always forget that.
It's
I'll,
just it's cons. It's literally just cons.
okay, so you're saying that this is this, but the accumulator goes at the bottom.
Yeah.
Is this what you're saying?
Now it's better. Now it's better. Um, yeah, the list will have the constraints in the opposite order that we read them,
Yeah, but that
but
doesn't
that's
matter at
not
all.
a. It will matter if we have to serialize this again, because then we will end up reversing the order every time we do a round trip.
That's true. I can't disagree, but it's fine.
I think that should work.
No, but do you understand what you're proposing, right? We are the this is the final moment. This is like constraints value. Do you understand that, right?
Constraints value,
This is it. This is the
constraints
entirety of
length.
the pipeline. We already serialize it.
The
Uh,
defined values, I think, is backwards at the end. The one where you take the constraints value and the length, that should be the length and the value. You
it
you
is
put it the other
reversed.
way around.
It is reversed. Thank you. It is in fact reversed. Whew.
Moment of truth.
No, but this if man, if this works first try, would be like a dream. Because if you really think about it, we didn't do anything that crazy to it. We didn't do anything that crazy, right?
Other than the fact that we are serializing code, you mean?
But that, as far as I understand, that's not a sin. Like this is a Lisp, so
It's not. It's not. But coming from another language, that probably feels weird, right?
I would say that the reason why it
Oh,
feels
I
weird.
just I just spotted a mistake, I think. You know how in the let's loop you were taking the how many constraints as the initial value?
Yeah.
That's in the other let, which is out of scope actually. You can I would
Where?
just inline that.
Well, which line, please?
Line 157, you define how many constraints in a let, which has an empty
Oh,
body.
okay, okay, okay. That's true. That's true. There, that's wrong. Here.
Um, you can just inline the integer bytes to integer in place of the how many constraints, I think. That wouldn't be too much of a problem.
That also works. That also indeed works. So you're saying to remove this, there, 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 and that should be it.
How fun!
Well, if it works, because again, we didn't
Um,
do anything that crazy if you think about it, because it was working just fine with just putting list here. Of course, it's not gonna do that anymore because now we are adding stuff when serializing as well. So that can give us problems. But if you think about overall what we did, I really don't think that should be a problem. We need to check the math though. Are we doing the math? So when deserializing a constraint individually, we are reading the size of the constraint in 2 bytes. Then we are actually going to constraint size plus 2. So this is the extent of our consumption, and that's exactly what we inform. And when deserializing multiple constraints, we grab the constraint size, which we just calculated here, and we just strip that amount from the stream byte. We just do that.
and
And
we also add it to the consumed bytes,
yeah,
which we
that's
are
really important
accumulating.
because we're gonna reuse this guy here in order to jump we need to jump 4 plus that. We need to jump 4 plus that in order to deserialize the fields. Which, if we ever want to swap the order, we need to make the interface of this guy return 2 things as well. Needs to do that. Okay, but it's time. It's time. Are you ready? And it's wrong.
It's wrong. Missing a
Parenthesis.
parenthesis.
Parenthesis. Line 132. Okay, so something is definitely wrong. Uh,
132 is a little above where we are.
no, no, no. But don't take that into account. I think we have an extra thing. Yeah, I do think we have an extra thing. This struct is getting big. Look, this is the entirety of the table. Oh boy. Okay, so actually, I think we should actually check the parentheses on each individual extra function that we made. So for instance, we have
uh,
this one,
you can
we have that, we have this, we have that, we have this, and we have that. Okay, so the serialization seems to be okay. Oh no, this is only this serialization of the constraints. Let's check this guy. So this makes sense. Oh, oh no, this is the end. Okay, that makes sense. That makes sense, and that makes sense. Next, this, that, this, nice. Next, uh, if that. Oops, what is this closing? This is closing the deserialize. This is wrong.
that's that's wrong, yes, it is.
Let's put the parentheses back. Okay, so something else is missing now. Uh, Wait, no, no, that parenthesis was right actually. Yeah, this is right. This should close on the deserialized constraints. That's for sure. Then values. This is the end of the serialization. This is the end of the struct, and this is the end of the no. This is the end of the interfaces implementation,
Yes.
and this
And then the next one.
is the end of the struct.
Let's try this again.
Oh yeah, let's try this again. Boom. Okay. Unbound identifier. Call with output to string.
That's not in the
Call.
standard. Well,
Is the search fuzzy? No, it is this name. Nice. Uh,
oh, it's called with output string. There's no two in that phrase.
there's no. Ah. Okay, let's try. Table
Table
constraints.
constraint.
So I must be doing something very wrong. Did I mistyped? Oh, it's local. Okay, that makes sense. Look at those warnings. Okay, good. Okay, let's
It,
check
it
main.
compiled apparently.
It compiles, but in dynamic language that doesn't mean much. So let's check the tests. Well, this, whatever those are.
Right now we're writing the tables without any constraints, right? We can try adding a constraint to one of them and see what happens. If it blows up or not.
Oh, wait, are we not doing that? Really?
I don't.
Which tables are we doing that? Write schema. So car table, procedure, test, and programmer table. So uh, car
Oh,
table.
the programmer table has a
Yeah,
constraint. Let's see
before
what
this
happens
was
with that.
working just fine because when serializing we were doing nothing, and when deserializing we were just putting an empty list in the slot of the constraints.
Yes.
Which is
Now it
actually
should do something,
which actually
I guess.
begs the question: what's gonna happen when we don't have constraints? Are we gonna have a bunch of
Uh,
zeros?
no, you're just gonna have the count of constraints will be zero, right? Which means we will see deserialize zero constraints and skip just the 2 bytes of the number of constraints, which happens to be zero.
No, yeah, yeah, but
And
that's the
then
thing. I don't think I ever tested this case. I never tested a table without fields, and we never tested a table without constraints. Now that we implemented,
we should test that
we should definitely
when we
test
get
that.
testing.
Okay, but this is good. This is gonna do it though. This is definitely gonna write it. This is definitely gonna write it, and this is definitely gonna read it back. So this is enough. This is enough actually. Oh boy, go, and it's broken.
And it's broken. Procedures, deserialization, byte string is not a
Uh,
well-formed UTF-8 encoding. That's a problem.
is not a well-formed UTF encoding. Bruh, what do you mean? Uh, 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 uh. Ooh,
Programmer.
that's a very huge problem because we don't know. It seems that it has broken in other files, not in the file that we just changed. That's awkward. That's really, really awkward. So let's search for this guy.
Read schema from this.
Read schema from disk. So this is in IO. Read schema. Please. Schema. Okay. Wait. Okay, so yeah, actually that doesn't matter that much. Because we can go here, we can go here, and we can go here. And there's a Racket there. And there's a Racket there, man. Uh,
There's a table.
and it's
There's
going before the fields. That makes sense. Hexel. Uh, Okay, that's really, really hard. Much harder to read. Fuck. Uh, okay, wait. So this is the programmer table. So this is the name. Okay. Then this is the this is the number one. This is how many constraints we have.
Okay.
So D1. So D1. We need to do the conversion. Ah, let's assume this is the amount of bytes of that lambda. Then we have a bunch of crap, which is basically the constraints. I'm gonna jump all of this. I hope you can see the other cursor on the right.
On the right,
Yeah, there's
I
another
can.
cursor as I move here.
It's a it's a bit difficult to see, but I can.
Maybe if I increase it.
No, it's actually because of the contrast, not because of the size.
Yeah, it's too close to my background. Anyway, so now it's doing that. Actually, wait. So that's it. We only need two numbers. So those two, the number one, how many constraints, and the D1. That seems to be correct, which of course means that the deserialization is the problem. Of course.
D1.
Yeah,
Uh,
D1 is the amount of bytes that this lambda took. I don't know how many characters is that.
I can check that. I have a REPL open. I can just do D1. That's 209 characters apparently. 209 bytes to be more precise.
Okay, so we can check that if you go to main and if you go to constraints. Um, Actually,
Uh,
it's from here to here. Emacs. Characters. Check, check, check. This is not what I want. Let's ask the Google, man. How many characters in buffer Emacs? Uh,
it's not gonna quite work because of the indentation. It gets stripped when we serialize it.
I was counting that maybe Emacs would have a way to strip the white spaces. That would be very useful.
Define thingy. I'm doing this in a REPL right now. One moment. Define thingy, and then the thingy is that.
That's actually
If
a
I
thing. Actually,
do,
maybe it's good enough to implement in eLisp and just add to Emacs. I was so fucking
without
sure there was
with
a way to do that though.
string lambda this without put to string, I think.
And I think I already know where the error is, by the way. Which function call in that mess is causing that?
String length, that's not quite correct, but it's 209. Yes, it's actually the right length.
Okay, so it did indeed work. Okay, so we did a good job on the serialization part of things, which is usually where we do a good job. Well, at least where I do a good job. Uh, let's try. I think it's this guy. I think this guy is fucking us. I do think so.
Lining by
108. Of course, it's not gonna
right,
tell me.
because there's a problem. I think I see the problem. The problem is actually that there's not a new line between the table name and the beginning of the constraints, which means it tries to read the table name and also the constraints. But the length of the constraints is not necessarily valid UTF-8, and that's why it's raising an error.
Wait, what? I don't think I followed the parts with the new lines though. Why that? Why should that?
We didn't
Why would that matter?
we didn't we didn't put a new line after the table name and before the constraints, right?
But that was it there a new line between the table name and the rest of the stuff? I don't think so.
Open the hack editor again, please, just so we can look at the thing.
One moment, please. Yeah, there isn't my friend. There isn't a new line.
And that's the problem. When you read the table name, you expect to be able to read an entire line, which means you actually read all of the constraints as well. And the length of the constraints is not necessarily valid UTF-8 because it's just an integer.
Uh, I don't think that's quite right what you said, but I'm gonna go here anyway. So what do you want to see?
Right. Go back to the. You have the table, and then you have the programmer, right? The which is the table name, and then after that, there should be a new line somewhere between that and the constraints, which we didn't put in the serialization,
Are
but we
you
probably should.
sure? Are you really sure of that?
I
Uh,
am.
okay,
I
you
am.
are. Okay, you are
Uh,
sure.
Because because we are trying to read a line from the byte string, right?
I I don't know if I believe. Yeah, I don't believe you at all. Oh no, this new
Oh,
line, what you're saying. Because there isn't a new line between the table name and the rest of it.
there isn't.
There
Huh.
isn't. There isn't a new line between that. The only new lines that we have is
Oh,
between entities, and between categories. This new line is artificial.
we
This is because the size of programmer is the same ASCII code as the enter. That's why.
But that's the thing, right? You have the table name, and then you have the editor, varchar, age, and all that, which are the table fields.
Yeah. Yeah, we have an editor, which is a varchar. We have age, which is an integer. We have name, which is a varchar.
And all of that is a single line, right?
All of that in a single line. Yeah.
But now we have the constraints in there as well, which is in the same line, right?
But that should be okay. Like in the
But
level of entities, within the
no,
same
no,
entity should be okay.
no. But then before the constraints, we have the length and counts of each constraint, right? The count of all constraints and also the length of them,
Yeah.
which is being read into that single line, which is the table description, right?
Yeah. I
But
still don't
the
see the problem.
table, the count of constraints and the length of each constraint is not necessarily valid UTF-8.
Wait, you're saying that the counter of how many constraints and the size of the constraints are not necessarily valid UTF-8? Is that what you're saying?
Yes, because we're just serializing the raw integer, right? As the 2 bytes
But
one
we are
after the
doing that
other.
already, man. There's a bunch of serialized integers throughout this thing. I think it's because we are using 2 bytes instead of 4. That's the only difference. This is the first time we are not using 4 size bytes for integers. We are only using 2. And that may break UTF-8 conventions or something.
It shouldn't actually.
But
What
but let
can
me tell
break
you,
it
there's a bunch of
is
integers here, man. I can actually show you if you want. Um, so before that, yeah, here. Do you see this number 6 here?
yes,
So this is how many characters of the name of the size. And this is an integer,
but
a
that's
4-byte integer.
but that's that happens to be valid UTF-8 because the top bit is 0.
Yeah, but that's the thing. So how do we know that? So in the other case, for instance, we have these two numbers, right? We have 1 and we have D1. And apparently one of those is
Uh,
not valid UTF-8.
the D1 probably.
Fuck. Okay, so what should I? We have two options, right?
Let let me try to make a breaking version of that with the current master. Let's see if that can happen. Git status. I'm in master already. Let's just restore so I don't mess things up accidentally. Then Let's see. The number preceding the field names tells you the length of the names, right?
Yeah, it should tell you the length of their names.
Right, which means um if we make one of those names have, let's see,
Are you gonna put an emoji
109.
just to troll?
Oh, if we make one of the emoji is not the thing that will break it. If we make the length be more than 127, that will break.
If the length of the thing is more than 127,
Yes.
yeah, that's fine. Like that's not a problem because we that's not never gonna happen.
It literally just happened
No, no, no,
with
it didn't
the
happen. No,
the
no, 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 no,
constraint.
no, no. It didn't happen. I think it happened because of the 2 bytes versus 4 bytes thing. It didn't happen because we exceeded 127 characters in the name. It happened, and I think we can check that. I'm not proposing this solution
That's
because it would be less
that's what I'm
efficient, but what we can do
just
is just to transform the choose to fours. That's literally something that we can do.
I reproduced the error in the master branch just now.
What did you do?
Line 47. Go to line 47 of main. You would probably want to commit the current changes into a branch before we do this because we're gonna edit some code
No, that's okay,
just to be
but
on the
you said 47?
line 47. You see the table name? It's
Yeah,
called name.
yeah.
I changed it to this. Let me post it in chat.
You use a special symbol to get over the ask 128? But that's what I
No,
said.
I
This is never gonna happen,
no
Marinho.
no. I changed it to that. You see on the chat, I posted a string. I
No, I
changed the name to
understand
that
that.
string.
I understand. I'm not denying that. I'm not denying that if you go over 127, it's gonna break. I'm not denying that. That just to make myself clear. I'm just saying
The
that given that the limit being 127, I think we are fine in terms of a database because that would be a name of a field with 127 characters. You may say that we can fix it and be even more general, but we're not gonna have extra utility because of this extra being more general.
The problem is that
Generality, I
this
think.
breaks. This also means the constraints have a 127 character limit.
That's not true because
Actually,
we just tested with 209.
and it broke.
No, but that's exactly my thing. We don't know at this moment if it broke because of the size of the constraint or
It
because,
is.
oh, you think it's because of the size of the constraint?
It
I
is because
I thought it was
I
because of these 2 numbers here.
yes, but that number is the size of the constraint.
No, 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 no. Let me make myself let me make myself clear. Are you talking about D1 and 1 or are you talking about these all of these other things here?
I'm talking about D1 specifically.
Okay, so how do I phrase this? There are two separate things. There is these 2 bytes in which the first is 0 and the second 0 and the second is D1, and there are all the bytes that follows. All the bytes that
That's
follows.
not the problem. The problem is the D1
Okay, so let me ask you, why changing this from 2 bytes to 4 bytes would not solve the problem?
because D1 would still be a byte that we are parsing as UTF-8 when we read the line, right? But D1 is not a valid UTF-8 byte on its own.
So your understanding is that how lucky is that? There isn't any number on this thing that is greater than D1?
No, because you see, for a sequence of bytes to be valid UTF-8, it either has to be 127 or less, each byte, which means the top bit will always be 0, or the top bit can be 1, but then it has to follow a very specific format, which we won't be able to hit by chance.
But that's still impressive. All this time, not caring at all, and we didn't hit that bug because nothing exceeded 127 here.
127 length. Yes, exactly. But now it did because it's code, and code can be relatively large. So we have a problem.
So that's interesting. Yeah, I think I understand now. Yeah, this wouldn't be solved by adding more bytes to it. This needs to be solved on the implementation level for sure. This is not like a minor detail.
I mean, we could change the encoding of the length instead of doing 2 bytes and just serializing it raw as it is. We could encode it somehow in a way that's UTF-8 friendly, like I don't know. I'm just gonna throw this as an example, base 64 maybe, but
I think it should be easier to just fix this because it's this call that is breaking.
it is that call precisely.
Um, so what happens if I do this? Is that a thing? Bytes to string.
No, it's probably not because in Scheme, the difference between bytes and strings is that strings hold specifically text, while bytes can hold arbitrary binary data. In order to convert bytes to a string, you need an encoding, which UTF-8 happens to be. You can't just do a raw bytes to string. That doesn't make sense.
No, I understand that, but I was assuming there will be other encoders. And this name is
There
great,
are.
unsafe.
Yeah, no, the unsafe stuff in Racket is clearly labeled unsafe. You're not gonna use them by
As it should
accident.
be. Rust has it, Haskell has it. Anyway, so how to solve this problem? If there isn't an encoder that does this, which I'm not familiar with, to be honest, I have no idea. But this should be like this is oh, look at this thing. This is weird.
Yeah, that's because in Latin 1, you can have bytes with a value higher than
How do
127
we know
because
the
it's
limits
it.
though?
I'm pretty sure Latin 1 is 1 byte per character. It just uses the top bits, so you have double the amount of codes you had in ASCII. But for UTF-8, UTF-8 does not allow you to have bytes higher than 127 because that would set the top bits, and if the top bit is set, then you have to follow a particular format, which is how UTF-8 works, which allows the UTF-8 to be a superset of ASCII and still include all of Unicode. Um,
Wait, so
the
should we use
problem is
Latin
that
then?
what?
Then we should be using that one because you said it has the double amount of spaces.
But Latin 1 only has 256 characters at most. Unicode has what? 40,000, 50,000? I don't remember the latest count.
But can we? How do we do that? How do we get the full blown? Is that a thing? Sounds like a
What?
third-party dependency.
What?
Because here we only have UTF-8 locally and Latin. And I don't understand. I
Yes.
don't know if those are enough because UTF-8 is 127. This is
No, no, no.
256.
UTF-8 is 127 if you restrict yourself to the ASCII subset. If you go up to arbitrary Unicode, it does allow you to have bytes greater than 127. It's just they follow a particular syntax, so you can't have them randomly show up in the middle of text the way it happened with us.
I understand that. I do understand, but then what's the best solution?
The quick and dirty way is to, instead of just serializing the integers directly, is we encode them to something that can be read as text, maybe like base 64 or something like that.
Yeah, but we're gonna
That's
have to
one
do that
option.
with all the integers, or because it would be kind of um, bad to have specific parts of the encoding to use a specific integer intermediary serialization.
Why?
Because you're gonna have to remember that. We don't have documents. It's easy to know why it's bad because who's gonna remember that?
Well, we can be uniform and call them all like that. But I don't think we want to do that actually.
I really don't think we want to do that. It's not about being hard, just to be clear. You can just do a replace string or whatever and just do some sort of trick to convert everything in the AST and everything in IO from integers to something else. Um, what is the other solution? You said this is the tricky fast solution, right?
The other solution is to get rid of the bytes to string UTF-8 that we were using and do some more complicated parsing to split out the characters,
Yeah,
the
that's
integers.
also a really bad option. Ah, that's bad. That's bad. Tricky, 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 tricky. And the worst part is that like Latin being 256, that's not gonna be enough because probably some constraints will be like much bigger than that.
No, no, with Latin 1, that's actually fine because Uh, it allows arbitrary bytes anywhere, which would fix the problem. But then we are parsing the text as Latin 1 instead of UTF-8, which doesn't seem like a good idea, like in the long run, because UTF-8 as an encoding is obviously better because it includes all of Unicode, whereas Latin 1 only has 256 characters. So, you know,
No, but that's the thing. I understand that UTF-8 has Unicode, but I don't. My understanding is that we can't unleash that power. We are locked to 127.
we can unlock Unicode. You can, in fact, let me just try this. If I change the AAA to an emoji, let's see, I don't have a good setup for typing emoji, so let's just copy paste one from somewhere.
A good
There should be
setup
one in
for
chat.
typing emojis.
Yeah, I have to fix my keyboard configuration, man.
No, but everybody
Specifically,
does. Everybody like that does English and other and it has a different native language that he uses in a computer. We are used to that, but imagine having like super space and then you are on an emoji layout, man. How weird would that be?
it would be great, actually, I think.
Weird.
Okay, let's see if I can copy that and get the actual emoji. I can, great. So there's an emoji in the source code now,
Weird.
and it works apparently. Got a different error this time. No value found for key name because I didn't fix the other stuff to use the proper. But yeah, the serialization totally worked. We can have emojis in the table names. We just can't
Yeah,
have the
we
table names be longer than 127 bytes. That will break.
How to fix that though? How to fucking fix that? I don't understand. How did you get an emoji if you only can have 127 things?
It's because UTF-8 is actually a variable length encoding. So like, if the top bit is 0, that means if the code point has a value of 127 or less, then in that case, UTF-8 is exactly the same as ASCII. Otherwise, if the top bit of the first byte is set, which means it's 1, which means it's a number greater than 127, then there's a particular format where um, the, the the following bits after the top bit will be a sequence of ones of length at least 1. That tells you how many bytes follow the first byte. And then the follower bytes have start with 1 0. And then the payloads are in the leftover spaces, basically.
Okay, so you're basically using the top bit as a flip-flop between characters and emojis.
Kind of, yeah. Not just emojis, any character outside of ASCII, basically.
Yeah, okay. But that doesn't fix the problem of 127. Ah, Ay, ay, ay. I mean, both options are terrible. Changing all the integer things to base
We can do.
64.
I have an idea. It's a bit cursed, but it should work.
Enlighten me.
What if instead of serializing the integers directly, we turn it into a code point, which means basically a Unicode character, kind of. And then we serialize that to UTF-8.
I don't know what you mean. Can you type an example in the chat?
Sure. So like, let's take the D1 example, which is 209, right?
209, I think.
If we do, I think it's integer to char, the function, that will turn it into a character, specifically this one. Let me post it in chat. 209 is that character.
Mm-hmm.
And then we just put that in place of the integer. And then we read by, instead of reading 2 bytes, we read a UTF-8 character, which can be variable length. And we just take the code point's numeric value, and that's the length.
What do you mean by code point correspondent value? You
Because
mean
the
mapping
way,
it back from the character to the number?
yes, exactly.
So I have a question. Why doing the why doing the normal way, which is just doing the integer itself, it breaks, but this would work?
Because in this case, instead of serializing the integer directly, which can produce bytes that break UTF-8, we're instead converting the integer to a character, a Unicode character, and UTF-8 is a Unicode encoding, so we just encode that character, but we don't care about the character itself, only its numeric position in the Unicode specification.
So actually it's kind of tricky because the number that we serialize, if it's greater than 127, that
You
will
take,
break. But if you take the
mm,
character, but if you take the character that is corresponded to that number in Unicode, that will work if we map it back when we deserialize it.
yes, as a bonus, this actually gives us variable length integers, sort of, for the length fields.
It is cursed, but I like it. It is cursed, but I do like it.
Okay,
Uh,
so the functions we need to make that work are these two: integer to char and char to integer.
okay, which integers are we going to do that? Because we have two levels, right? We have the outer level, how many constraints. That should never go over 127. Um,
Uh, I mean, if you want to be uniform, we can do this everywhere if you
no, no, no,
want.
no, no. We're not going to do that everywhere because this is going to be specific to constraints.
In that case, we should probably just do it for the individual constraints because they can get pretty long, right?
Yeah, they
But
can
if
get pretty
we
long.
but if we impose a hard limit of 127 constraints, that should be fine for the top level thing. Of course, we would have to chop off the other byte, which will always be 0, but that's life, I guess.
Oh, you mean because we are doing 2 bytes, right?
Yeah, we are currently doing 2 bytes for the number of constraints. We can do just one
Wait,
instead.
wait. I have a question.
Sure.
How many? Let's suppose that we are using this strategy for the individual constraints. What's the max number of characters a constraint can take?
What's the maximum integer for 21 bits? I don't recall off the top of my head.
Oh, so the max, even if it's variable, the UTF-8, it can go up to 21 bits?
I mean, if you wanna be really really strict, the general form of UTF-8, which is what was originally defined for Plan 9, can go up to 64 bits, I think.
Fuck.
But since Unicode itself is limited to 21 bits, that's the limit for the spec for
Ah, that's
UTF-8 as
more than
well.
enough, man. That's more than enough. We don't even need to have the zero for the individual constraints. Let's just do one char then. Wow, that's 21 bits. I need to know more UTF-8 stuff then. Um,
Uh,
so it's this one. So this serialized constraint and this serialized constraint will be the two ones that we're gonna change. Um, so you said we're gonna do integer to char, and I believe you. I believe we're gonna. Oops.
Actually, if I remember correctly, I think Racket supports the generalized UTF-8 as opposed to the official one, so we could go all the way up to 64 bits, I think.
No, but that's
If
just like flexing without the necessity to flex. Uh, how do we do that? Uh, so is there like a char bytes?
um,
There isn't. That's not a good sign. So we do
there's
have
right char,
right char. Oh, it's the same thing, but for chars. But for chars. That's really
and there should
annoying.
be a and there should be a read char as well
Yeah,
somewhere.
that's really annoying though, but that's okay, I guess. So how we're gonna do that? We're gonna do call with output string. Uh, I'm so fucking curious to know what Magneto will think about this. He's gonna say immediately that he's cursed, but he's gonna say I like it. He's gonna say, dude, that's cursed, but it works.
Oh boy.
Ah, so good. Right char, and the out comes after because of some random people against composition. Okay, that works.
No, actually, the reason for that is because for very, very minimal implementations of Scheme, which the standard does support, you may not have a case lambda, which allows you to do arbitrary arity overloading of your functions. Which means the only way to have optional arguments in that case is to take a variadic number of arguments, but that limits you to putting the optional arguments at the end.
Mm. I understand, but I already discussed that. I understand the implementation, the programming languaging engineers limitations, but I don't care. I'm the user. You are the
That's
ones
fair.
that should please me, not the opposite. So do we have a call with input? We do. Cool. But that's not quite what we want actually. Well, it is actually hard to
What
tell.
what
Input. Um,
all with input string and then you want to read, right? Something from
yeah,
there.
I want to read. I want to do that.
I think
And then
I think
read.
it's input.
Go on. And then we're gonna do the trick.
Uh,
Char.
you have to pass the C port instead of the subbytes thing, I guess.
I have to do what?
That's not quite. Wait, call with input
Oh, read
string.
char. Read char. You're right. I forgot to
It's
put the
call with
port.
input. It's read char instead. Yeah.
Okay, so it's. Wait, what? I don't know if I follow this. So I need an input, but I don't have that.
C port is the input.
Yeah, I know, but Um, where I'm gonna put this?
You don't actually,
What do you mean?
because you're going to read a variable number of bytes now.
What?
Yeah, read char reads a variable number of bytes.
But that's not what we want actually.
It
Which
is.
reminds me, we
It,
need to redo the math. I don't think we redid it. Redid it the math.
we have to redo the math, yes.
Uh, so this guy now is a number one thing. So
No, it's actually one character, one code point,
yeah, so that's
but
one
it could
byte.
be no, it can be actually as many as 4 bytes.
Oh, so we don't know the size of this.
We don't. We have to call the byte length of the
Yeah,
of the
yeah, yeah,
thing.
yeah, yeah. No, but this is serialization. Does this matter? Let me check.
Serialization? No, I don't think
What
so.
happened to this guy? Serialized count, serialized blah. Yeah, for the serialization doesn't matter. You're right. I think I'm getting tired. That's a sign. Uh, let's go back to this because I think I am more than confused now. So we want to read a char from somewhere, right?
Yes.
So how does that work? We want to do this actually.
No, we don't.
No, no, no. Actually, that you're right. This is a variable thing. This is a variable thing. Ooh.
Here's what we do. We do a call with input bytes with the bytes array.
Call
We read a char, call with input bytes, yes, with the byte array as an argument.
as a byte
Uh,
array as an argument where.
I think it has to be the first argument of the call with input bytes, if I'm not mistaken.
Oops. Mm-hmm.
And then we do a read char, which reads a single character,
Yeah. Then we convert that to integer.
and we convert that to integer. Uh, I'm trying to think what's the best way of getting the byte length of the character. It's not coming to me, my mind. I'm getting tired as well.
I also noticed that the highlighting changed, so it did something wrong. Oh, that's wrong. Uh, okay. Um, okay. We don't know how many bytes we consumed, right?
No,
Okay.
read char.
We don't know how many bytes we consumed. How the fuck we're gonna discover that? That should be a function. Oh, there
There,
should be something.
there probably is char to
Oh,
integer, char
we need to
array.
detect, we need to know the size before converting back, man. That's
What?
tough. Yeah, I think that
No,
if
we
we
can.
do this, that immediately doing this, we're gonna lost it.
No, we don't because from the worst case scenario is we have to serialize it again and count the bytes of the serialization bytes.
Yeah, that's terrible. But the reason I'm not proposing anything better is because the only thing that comes to my mind is mutability.
No, man, there's no mutability there. It's just
No, we can solve the problem with mutability just fine. But I don't want to do that.
uppercase, white space. I found it. I found it. There's a function called char utf8 length.
Ah, that works. So this is gonna be like constraint. No, wait. Um,
Consumed byte, I guess, for the constraint. Huh.
constraint size consumed. That's fine. And then char to what?
No, it's not you. It's char utf8 length.
UTF-8 length, and then we pass the constraint. The constraint. Ah, I can type size, and then here.
And we don't need the char to integer at that level, I think. Let me think.
I really think this is
Uh,
right though.
no, what I mean is char to integer, that's the constraint size. But then we have to do an integer to char for the char UTF length to
Oh,
work.
so we do have it to convert it back. That sucks.
Not really. I
We could
mean,
do
it's
a
just
let in
literally
this lambda and return values, and then do a define out of this let.
nah, just do the conversion back again, man. It's literally just
Ah,
manipulating bits in a
that sucks.
no, it's literally just changing a type tag.
That sucks. Not a fan. Because you already have that information here. Do you think that's it?
Constraint size plus 2 is actually wrong.
Where is the plus 2?
Values plus 2 constraint size.
Oh, oh, I'm sorry. It is actually um, constraint size consumed. Yeah, that's the thing. I think this n might be wrong as well because there's a 2 here.
Integer, it is wrong. It is wrong.
But that's another battle though because now we don't know this number.
No, it's
Ah,
literally the same thing. You just did read char, char to integer. You just have to do that again in this other context.
but which part of it? This?
Um,
Fuck. Or I'm gonna have to do all of that. I think
let's
I'm gonna have to do all of
see.
that.
You have, we can extract that into a helper if it helps. I mean, that's the point of a helper, right?
Fuck. Not a
Um,
fan. Not a
and
fan at all. But okay.
by the by the way, speaking of being tired, I'll have to go soon-ish
We are so close, man.
because
We are so close. Character. I'm gonna say actually. Can I do you? Can I use names in the numbers in the names? UTF-8 character
you can, as long as it's
as
not the
integer
first character, you can. If it is the first character, it depends.
as byte
Because
array. Then
team lexical syntax
we're
annoying.
gonna do this.
You totally can.
Um, okay, here I'm gonna do like that.
Let's
No,
see, be the character that we read, and then
and then values.
you forgot a name for the thing in the let.
I forgot a name for the thing in the let.
Yeah,
Oh,
the way
oh,
you're
yeah,
doing
that's
that,
true.
you're
That's true. That's true. That's true.
yeah.
That's true. That's true. So this is a red, well, char red. And then the values. What's the convention again? The convention is
First,
first the
however,
size, then the other crap. So it's this char
and
red,
then
and then
and then we
char
do
integer char red.
you forgot the greater than for the arrow in the chart to integer.
I forgot. Yes. Okay. Um, Num, num, num. So now define values. So let's use the same names. So constraint size consumed and constraint size, and then we're gonna pass to UTF-8. Yeah, this is certainly one of the most cursed things we have done.
I like it. I like it. I mean, UTF-8 is a good format, man.
I'm not denying. Nobody's denying that. But I mean, if you look at it, you're just gonna say, "What the freak were you guys thinking about?" But now that we have that, we can just fuck.
Oh, but now we have a bit of a problem. I just
Sure.
realized.
Tell
What
me.
if,
Tell me more about it.
what if,
I
um,
should have committed before we started doing that.
no, no, I mean, it can work. It's just we'll have to think about it because what if the character happens to be, what if the length happens to be 20?
Are you talking about a new line again?
Yes.
If it happens to be 20, uh, the function that I did to fix that the first time
Actually, it's not
should,
20, it's 10. But
yeah,
yeah.
my function that I did to fix that should all the individual new lines, like new lines that are alone, only with the new line symbol, they will be they will be pushed back to the first non-empty uh, new line, new non-empty line. So that means that it probably is gonna break if you have new line and two new lines in sequence empty. I think that's the case where it's gonna break.
Yeah, that can happen if we have 10 constraints and the first one has 10 characters.
uh, uh, but that's just a matter of fixing the helper function or improving the deserialization, which be my guest. I'm completely okay with people helping me with that. Anyway, so I already forgot. We were doing this because of this guy, right?
Yes, we were.
So now my question is, I know where one of these values is going to be used. This one we're going to use. Do we need the other one?
I think we do actually.
Where?
Consumed byte,
Oh, it
consumed
is
byte
in
plus.
itself actually. No, no. Wait, what?
We deserialize the constraints. We start with an empty list. We consume 0 to begin with. And then, yeah, it's the return value. It starts at 0. We add the constraint size, and then we loop.
I'm so fucking confused.
Ah, okay, wait a moment.
I'm
I
so
think the
freaking
consumed bytes was wrong to begin with. It should have been 2, the initial value, instead of 0, but okay.
Wait, where?
Line 167. We initialize that to 0, right?
Yeah, which is true. We don't know how many. This is the beginning of the process.
Oh, right, this is the beginning of the process.
Yeah, but
This is
I
the
don't quite
beginning.
follow because we're gonna call the same function here again because this true is not gonna be true anymore. It's gonna be something else. My question is, what about the other thing? What does this mean in this context? What does that
Chart to
mean?
integer. Chart to integer would be the number of constraints. It would be n. That's correct. But then the other value, which is the consumed size, um, I just realized we had a bug actually. The consumed byte should have been 2 to begin with instead of 0.
Should be true.
I mean, now it's gonna be a value that we have to figure out when we call UTF-8 character as integer, but
Yeah, but I'm still confused. So we're gonna use UTF-8. Whew, UTF-8 character as integer. We're gonna pass the byte array to it. That's gonna return us. Oh, this is how many constraints? This is how many constraints. That makes sense. So this is like how many constraints
Constraints.
consumed, and this is how many constraints. This is how
Yes.
many constraints. So now the question is, I do see. So
N
n
is how many constraints?
is how many constraints, but the consumed byte, as you just said, is going should be this from the starters.
Yeah, and then the string B, we have to skip the how many constraints consumed as well
Do
with a
we?
subbyte. We do, actually.
Do we? Do we? You are right. That's not what I want. That's still not what I want. Thank you. Subbytes. We want to go from 0 to how many constraints consumed.
That's not correct, actually.
That's not correct. Yes, you're right. This should goes here.
It's still not correct.
I have a very hard feeling it is. Oh
Uh,
yeah, it
if
is
you do
correct.
subbytes, if you do subbytes byte array 0 to how many consumed, that will actually cut
Oh,
out
that's actually
only.
that's just going to do the opposite than what I wanted.
Yeah, now it should be right, I think.
Ah.
Now, as long as we have any number of constraints that is not 10, and
Actually, we should make a to do for that because that's for sure a thing we're gonna forget. So let's change the mode.
oh,
So this function right here, let's actually confirm the behavior of this. So if it's a new line, if the new line thing is set, that means that we encountered previously an empty new line. We're just gonna append. Uh, we're just gonna append the new lines with. Wait, new lines. What the fuck is new lines? What the fuck is that? Wait, where
new
where is
lines
this?
is
Where is
is
this thing coming to be? Oh, in the
it's the
lambda.
argument to the
Okay,
lambda.
so this is
Yeah.
the accumulator actually. And then we are just appending the new line to the next thing. So if it happens that we have two new lines in sequence, empty, the first time we're gonna set, then then the next time will come. So
Yeah,
this is
we
gonna be
really need to
another empty new.
improve
This
that.
is gonna be another empty new line. That makes sense. Then this is gonna be true because the previous thing was a new line. We're gonna return that to false. Then we're gonna append. So this is like an empty new line. No, this is the accumulator, so this doesn't matter. But this is an empty new line that we are just adding another one. And this check will not be enough because now we have a line with two enters in it, which which is not going to work because this needs to be appended to the first real data line that comes. So in the case of in the case of a 1010, we are just fucked. So uh, to do. Actually, this is even worse. So I'm gonna put a fix me. With the addition of constraints. Are you there, Mari?
I'm here.
With the addition of constraints, there can be multiple new lines in sequence. In sequence, um, and this stupid thing will not
Typing.
work anymore. Good luck. Uh, okay.
That's that's so great. That's so great.
Ah, okay, let's do it then.
Let's do this.
It's It's already 2 hours and 40 minutes. We are here for oh, it has been a while. Please. Okay, that's a good
Oh,
sign, although not necessarily a great one, and it didn't work. Oh, bytes
you read
append.
a you read a string instead of okay.
Bytes append. So somewhere in here we are appending something that we cannot append.
Oh, it's because the constraint size is called with output string, not output bytes.
Ah, and then I put right char here, right?
I think it's correct still.
Ah,
Okay, things are happening.
no, and it's broken. And it's freaking broken.
Ending
Ending
indexes.
index 181 million. Ah,
I
so
think I
something
think
got.
they messed up somewhere.
Uh, wait, the serialized hash. Oh, the math. The
The
math,
math
man.
is wrong.
The math needs to be wrong. Because look, we broke on the deserialized hash list. That means that we did something, and now we are trying to read fields. But I don't quite understand how that's the case. I really don't understand how that's the case. Uh,
Uh, Let's see. Digitalize. Print size consumed. Char to integer. That's right, I think. And then constraint size plus. Oh, constraint size plus constraint size consumed. That doesn't seem right.
where? Which line? Give me, give me.
163.
163. Uh, nut, nut, nut. Mm, I don't know. It seems right to me.
But the
Maybe I'm.
constraint size is oh, oh no, that's the bytes and then that's hmm, that actually seems right.
Yeah, because
Okay.
you
False
have the byte
alarm.
array. So we are reading we are reading a char, which well, not a char per se, but we are reading a number that was represented as a char just for the sake of implementation details. And this has a dynamic size. We don't know how many bytes we use to write that motherfucker. That means that we need to jump those. We need to jump that amount, which we are doing here, because we already consumed that. And we want to read until constraint size plus that, because we're basically shifting
Okay.
the window. And then when
And
they
that
ask how many we consumed
that's
exactly this
also
amount.
okay. Yeah, that's right. It was I was wrong.
No, but that's completely understandable because I can feel it. It's palpable that we are getting worse. Uh, but what I don't understand, actually, let me see the error again. No, this is for sure a problem with the fields, which means given the byte string, we did something fundamentally wrong.
Huh. Consumed bytes, we start with how many constraints consumed, and then uh,
There's a way to check this. Uh, there is a way, which is print read lines. This is what happens when you do serialization for a while. I already know what should I pay, where to put prints. Uh, I'm actually gonna delete this thing because it's annoying. Okay, thank you very much. So each one of these things, space by spaces, is a line, right? Is a line.
Okay.
So we have a procedure, and then we have the name of the procedure section. Then we have the procedure itself, and that's it. Makes sense. Then we
Okay.
have the
Then we have
table
table.
section to identify that we are changing. Here's the new line, so my method worked. uh, so now we have programmer. Then we have this, which I'm assuming is the character.
Yes.
Then we have all of that, and that ends here.
Uh, line 3 actually.
So it's to here from here to here, which makes sense.
That checks out.
Then we have car, blah. What the fuck is this? Oh no, this is a print because this is not a println. So this is basically a print, and this is something else. Because this is the effect of deserializing a procedure. We just print on the console, which we did. We deserialized this, and it worked. Okay, that means that it's not a new
Man,
line problem. It is not a new line problem. That's what it means.
it's a math problem.
It really sounds like a math problem, but
Let's
I
see
can't
how
tell.
many. We, we take the consumed bytes and be constraint size, which. Um,
I have no idea where we are doing. I think the math is right. We don't have choose, man. That's the criteria. Well, there is one here actually. Oh no, but this is the chew that we. Oh wait. Oh, we can't mess those around. We can't mess those around.
yeah,
It was right. We don't need this crap, man.
we don't.
Yeah, because this is always the chew because this is how many constraints.
Right, the number of constraints is. We should probably bump that down to one, but yeah, you're right. You're correct.
Let's bump that down to 1. So this is going to be byte array 0, 1. Um, 0, 1, which means that
False.
this is 1, uh, and this is 1 as well. Ah, fuck. So dumb.
Ah,
And this is going to be a
got
number
ahead,
1.
got ahead of ourselves, I guess.
No, we are getting worse. That's the problem. Whew,
Let's try this one more time. One more time.
although it's nice to have the function, the helper. I'm gonna leave it. Uh, okay.
It's very handy. It's
Yeah,
very handy.
the consumed bytes is always starts with 1 because the first byte is always gonna be the amount. That's the problem. That's the fucking problem. I don't care. I'm gonna YOLO it.
YOLO.
Ah, I thought it would work. Fuck. Integers
Integer
bytes to
bytes to
integer.
integer
Arity mismatch.
parity mismatch. Oh, right, because we need how
What?
many bytes are we reading and is it signed or not?
Ah.
166. It's one
So it's
byte,
gonna be 1 and false.
which means actually you don't need the sub bytes, do you?
What do you mean?
If you're reading one byte from the byte array, you are already specifying the length. You don't really need the sub bytes, do you?
I don't know how that works, but let's try. I actually have no idea what's gonna do. Being a dynamic language should be okay in this case. It would help.
Even if it was a static language.
Length
Oh,
is not one, two. Yeah, it doesn't. So it needs to be in the length that you were specifying. It is not that smart.
Ah, okay.
Wait,
Did it work?
I don't know.
It
What is this?
Yeah, that's not right. Syntax input part string. That means we are passing some. I mean, the serialization kind of works. It's just we are passing a wrong argument somewhere.
We are passing a wrong argument. I have
Somewhere,
no
yeah.
idea. I have no idea what you mean with that. Um,
Um,
well, actually,
it's
actually we have a better. Maybe this is just a representation. Maybe after converting it back to datum, it doesn't. It just like lost. It lost the printability or whatever. I have an
no,
idea
it
to
should have.
test that. We can copy this thing. We can copy that, um, and we can do the following. We can instead of specifying programmer table, we need a table, right? So we need a hash ref. Ah, thank you. We need a hash ref, and what I'm gonna do, I'm gonna grab the
Uh,
programmer table out of the schema, and I'm gonna try
Real
to check
quick,
the local constraints.
can we take a look at the MDF outputs real quick?
Here we
Yeah,
go.
the output. Yeah, the output is actually right. It's just the reading back is broken.
I'm gonna put all my things in the printability. So let's test this. Literal data is not allowed. Okay, so it's not just a matter of printing. It is a conversion problem. Interesting. Very, very interesting.
Uh, Deserialize. Deserialize constraint. We are returning the constraint, which is datum to syntax with an F. Open input bytes. Open input. Oh, right. Open input bytes. I see the problem. I see the problem. We are opening the input bytes and then we're not actually doing anything with it, and then we are just stuffing it into the syntax.
Wait. What does that mean? Let me check again what open with.
It opens a port that we can read from. We're not actually reading from the port. You forgot. Yeah, we missed a call to read there. Just
Okay. Read.
read. That should work, I think.
I have no idea how to indent this. So good luck later. Oh, man, it's broken.
Oh,
Oh,
but it's broken in a different way. It's
wait.
because
This seems like context stuff now.
it is. We passed F to the context, so it doesn't know what lambda means because there's no lexical context,
We fixed
which
that
means
already when we did the.
no, no, no. That's actually right. Go
No, no,
back
no. But we
to the
fixed this
deserialization.
before. Check. One
No,
second.
no, no. But it's because remember when I
Evolve
mentioned that
syntax.
yeah, no, but go back to the deserialization. See the hash F
Yeah.
changes to hash quote
Hash quote a.
a. Yes, and try again.
What is that?
What that does is hash quote a is a syntax value,
Yeah.
and it has whatever lexical context happens to be in effect at that point in the source code, which means we actually have some context as opposed to none, which means it works. Lambda is bound in that context.
Yeah, but why hashtag quote a? Like this is like this. It sounds like a magical sequence of characters that just gives you context.
It's because we're writing a literal syntax value, which is just the symbol A. But because it's syntax, it has whatever lexical context it has at that position in the source code.
Hmm.
That's where the context comes from. It's literally from its position in the source code.
I don't know how that gives it context to know what's lambda. That's kind of weird. Because what at this point of the code tells it that?
Uh, I have I have to admit that I'm not entirely 100% sure on how the macro machinery for Scheme specifically works
No, that's
because it
okay.
does a
But
bunch.
I believe you. But it worked. That's okay. Uh,
Yeah, we will have to replace that A with something better later, but that's for later. That's for future us.
Something is returning true, man. Again, this is the ah. Something is fucking returning true. Do you know what?
I'm not
Check
sure
local
actually.
constraints. Oh, this guy seems to be returning true.
Yeah, it returns true.
How can I do that? Is void?
You just have to. Um,
Oh no, 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 wait. In this case, we do want to know the truth, if it's true or false,
it,
because this is a check. It
it
makes
is,
sense. Uh,
and yeah, it is.
so it is
That's
perfect.
correct then. We're done, I
Look,
guess,
look at the
for now.
lambda. Okay, wait. We should make it. We should add another constraint to see what happens. I know we gotta go. I know, I understand that. Uh, but this is gonna be super fast because we're just gonna rename this to true. We're gonna check if what other fields we have. We have editor, and let's suppose that this should be fuck greater than 100. 100 integer 32 raw value. Yeah, yeah, that should work just fine.
Add
So
it to the programmer table. So we have two constraints there instead of one.
yeah, constraint true. The check will fail though because I think some of the rows that we have are not.
Oh, editor is a
Oh,
string instead of an integer.
that's true. Okay, so let's do string. I think this is string L. And let's grab the length out of that.
That works.
But this is
It's
too big.
string
Let's
length
put
instead
5.
string length instead of just length. Length is for a list.
String. Okay, sorry for that. So we are doing that on the editor. This is definitely more. That's very interesting.
Run the code. Let's see what happens.
Wait, man, this is really interesting because the local constraints can clash with the field constraints. Wow, how the heck are we gonna handle that? Ooh, that's gonna have to be on the compiler level.
But the a
Fuck.
field con- but a field constraint is just huh.
Because this is like dependent typing in this case. But this is the the literal definition of the string type. It is the length of it. Okay, that is kind of sort of dependent also because this is actually restricting to a minimum value and this is restricting to a maximum value. But they can contradict each other.
They can. Yeah.
Fuck. That's gonna be a terrible headache, man. Terrible. How many characters do we have here? 5. Okay, so this is greater than equal. Thank you. Okay, that should work. And it's broken. But I don't think we're gonna fix this now. But it is broken. It is broken. Let's see the. This thing. Ooh, serialization seemed to have worked. Which I guess it means again that the deserialization is the problem in again. So,
Man.
so how does that work actually? Actually, we can check that out. Hexaml. Um, yes. Ooh, there's a bunch more code now. And it's
um,
oh, it's here. It's definitely here. So there. This is the beginning of the second lambda. This is the beginning of
yes.
the second lambda. The question is, where is the size, right?
It's the those two dots between them.
It's the two dots. It's the two dots. Yeah, unfortunately, we're gonna have to tackle this another time. It's already 3 hours. Sad, really, really sad. We are so fucking close, and we didn't test the. I want to test this before we finish. So let's actually remove all the constraints. Let's actually do that because it's gonna be quite sad if it just works with one. Oh yeah, it just works with one. It doesn't work with zero and doesn't work with numbers greater than one. Ah, perfect.
Oh boy.
It's a
Oh boy.
perfect thing. Oh, this actually is helpful though. It's saying that it's in the deserialized hash list, which means that something is wrong with the goddamn constraints. With the goddamn constraints. How that how can that be? I don't understand.
I don't know, man.
Oh, but there is a way to know. Uh, how is that wrong?
Syntax.
That seems right. That
It
seems to
does seem
be
right.
that does look right. This is where we finish the first constraint, and this is where we go to the second constraint. So that means that the math is wrong.
The math is wrong. And the
How?
sad thing is, it looks like it's an off by two error instead of an off by one. How did that happen?
What? What do you mean?
Yeah, go back to the error message.
No, you say
Says
this?
no, it says any index 10 values from 0 to 8. That's an off by two error, not an off by one. So what the heck happened?
That's wild. That's really wild. Because we are saying that we are starting from 1. We are saying that. And the string B also starts from 1. How does that make any sense? Did we change the... Yeah, on the deserialization count, we also changed that to 1. Um, okay, I do have a test. So grab. We're gonna do a favor for me because you did this before.
Yes?
You're gonna grab this. You're gonna grab this. I'm gonna send it in the chat. You're gonna have to remove some crap inside that because there's still a syntax and then hashtag and less than
Okay, that's
syntax.
fine.
And then count the characters there. And while you do that, I'm gonna do the print of the println constraints length because the length needs to be wrong. The length needs to be wrong. I'm gonna be really surprised with this one. Okay, so the answer is 439 here.
Um, you counted from the beginning to the end. Did you include the two length markers?
Did you what?
The length for each constraint, did you include that in the count?
No, I'm summing them up.
Oh, right. Okay. In that case, let's see.
Oh wait, yeah, your question is different actually. Your question is if I am counting.
When
I'm
you're summing
counting
them up, are you
Yes, I am. I am counting +1 for the size of them. Of how many? So this is 438, right? So this is 438 bytes
for both of them, right?
for both of them.
Oops, I messed up.
What the F?
Line one quote and
I
then
really don't understand this.
copy paste.
Blah.
That
Yeah, you
looks
jump
right.
4,
And then
and then you jump the length.
define two to
Which
be this.
beat?
That's the editor and the age, and then um, with output to string. I'm just gonna copy this.
How does that make any sense? I don't understand the problem in the math. I don't understand the problem in the
Write
math.
one, write two, and then string length. That should give me the sum, which is 434 apparently.
For wait. So there's the problem. That's exactly the problem.
But there
Uh,
should be at least two more bytes for each one if we include the length before the actual strings, which should give us 4 extra bytes, which bumps us to
438.
438. Yeah, that seems correct actually.
Uh, I'm out of ideas now because if the math is now wrong, what the fuck happened? Because we seen that it worked with only one. Why with two is just breaking apart? And we know it worked because we know the size and we know what it made up. We know that. We know that. I'm actually curious to see what this is. Fuck. No, not that. Well, that's not gonna be very useful because I don't remember what should be because it's been so fucking long.
It's the editor and the varchar and some other crap.
Um, I don't remember what is the one, but I know this is the size of the name of the field. This is 6 letters. Oh, this is the row I. Is this the row ID? No, no,
Wait,
no. This is the
it's
position. This is the position. So the editor is the second column. That's what it means. Then we have A, and A should be this amount of stuff.
A is 10, but varchar only has 9, 7 characters.
A is 10. Are you sure about that?
Yeah, 0, 1, 2, 3, 9, and then 10 would be A.
Wait.
It's the other varchar, I think.
No, it's not the
Maybe.
order because it is the one with the editor. So it needs to be this one. But you're right, there's no way
Ah,
here. There's no fucking A. What did we do?
there,
Why? I,
there's an A 3 lines below you.
below me. Here. Here.
That seems unrelated though.
That seems unrelated. I think it should be whatever this is. I really do. But we know it isn't. We really know it isn't. And but I don't understand. How is this affecting the other people, the other stuff to deserialize? That doesn't make any sense. But there is a way to know. There is a way to know, which is commit this. Um, I could stash it, but
Make
I rather commit.
make make a branch first.
I'm already in another branch.
Okay, that works.
Uh, Uchu. There's a fix me. Okay, so let's just. I'm not gonna stage that. So let's say so add constraint serialization for tables, and we're gonna push that right there. Then I'm gonna remember what the fuck is the commit. It is B, not the commit. I want to do a checkout. Spit new branch. I don't want any of that. Checkout, checkout. I always forget the ones that are not the first. The first remote merge push. Why I always don't remember checkout, man? It's so dumb. For some random freaking reason. It should be branch. I don't want any of that.
It's B apparently.
B. Yes. So they should rename that for sure. Okay. Now it comes the real deal. Now it comes to the real deal. You know why? Because we can do this. Print ln sub bytes byte stream 4 4. Then not that that. This should give us the fuck no
Things are happening.
no here. What does that mean? It is the same crap. It is the same crap. Why it is wrong? Why is that wrong? Oh wait, that makes sense actually. The rest of it was completely removed. Ah, uh, so B. Let's go back to here. Oh, I didn't. Ah, fuck. Origin master, and now B there. Okay, that's the thing. That's that's the thing. What the heck happened with the rest of them? We lost bytes along the way. What does that mean? Wait, what? Did we
Let me
lose
check.
data before? I don't
Let me
remember the
check
print.
something real quick. Read line.
What the fuck? And I should have saved that. I didn't because I'm stupid. This is wrong. Here's the problem.
Where?
What? What do you mean? What in the fuck happened? Did we reach some sort of limit? This is a serialization issue. This is not a deserialization issue. For the first time.
Oh,
For the first fucking time.
serialization. I see.
So something
Okay.
got wrong. But what is wrong? What in the
Might
fuck is wrong?
append strength.
Oh man. Ooh. Theory number the uno. My function is fucking us. No, it is not that. What the fuck happened? It is not the
Procedure
function that adapts the new lines thing.
table.
How does that make
Programmer,
any
lambda
sense?
rows, whatever. And then the other one is lambda rows. And then
I'm starting to be really skeptical. I have no idea what the fuck is happening. I want to print this because I don't know where we are missing the data. Because you saw it, right? We are missing data. Let me
yes, we are.
show. Okay, some parentheses. How nice. Of course. Thank you. Uh, yeah, it is done. It is lost. Here's the rest of it.
It's in
There's a
another
new line.
line.
There's a new line.
That's the problem. I see.
I
So
don't.
why is there a new line? Oh,
I wrong. I don't. No, it's okay. But this confirms that the serialization is indeed working,
it's
right?
just we inserted a new line there somehow that shouldn't be there, but yeah,
No, no, no. But that's the thing. That's the thing, Marinho. What is highlighted on the screen right now. This is exactly. Well, I actually can't say for sure because is what is this crap? Oh, this is the older table. Okay, that makes sense because we're calling serializing two tables. That makes sense. So this means that we are writing. Why we are not? Well, we are writing correctly, actually.
it's just there's a stray new
Here's the
line
new
there
line.
somehow.
Here's the fucking new line. So so it is. No, wait. It is not my function. It is not mine because
What?
mine. This is not mine. This one.
I have a question.
Go
Are
for
we
it.
making sure that the field names don't have new lines? Because that can be a thing.
No, we are not making sure that. But we can make that in the
Uh,
guards. Doesn't matter. Actually, that's a lie because to the tape. Oh, you said the names of the. Which names are you asking actually?
uh,
The names of the fields?
like the field name,
Yeah, so
like
we can make
Barker,
that in the
whatever.
guards, no problem. The problem that I really don't understand is what are we doing wrong? Because, see, this is not passing into my function, the function that does all the craziness of the new lines. This is doing raw, this is reading raw data. And how in the fuck is this not grabbing our stuff?
Yeah, the new line is basically breaking it into
Oh,
yeah.
that's the next thing.
It's the next thing.
Ah, yeah. I think we can't. I think we can't. we can't procrastinate more on this. We're gonna have to change the. Oh man, I didn't want to do that though. Suffering, suffering. That's what we get to do for doing recreative programming, man. So fucking sad, man. So.
We tried so hard and got so far, but in the end, it didn't even matter.
I like that song. Uh, wow, that's really unexpected. It's really,
How did
really.
that new line get there, though? I'm still wondering about it. Like how?
And you know what's weird? How is the new line affecting this branch, but it's not affecting the master? Because this is the same fucking table, right? It has more stuff in it, like this Racket code, but it's the same crap. How this is not a? Oh, I changed the numbers, right? Maybe I changed it.
Which numbers?
That number. Ah, fuck us, man. That's the conclusion of today's session. Fuck the
W-
number 10.
Why? Oh, right, because it's a number 10.
And it works! Now it works!
It's a number 10. Hey,
I
hey,
changed it! I.
remember when I told you that the number 10 is a problem? It's only the number 10, and you go and choose exactly that. It's like,
Okay, that's one part of it though. Let's test if nothing. Please, 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 just work. No number tens. Yes! Oh yes! Oh yes!
number 10 is officially banned from this code base.
We're gonna have to fix that though. We're gonna have to fix the serialization to not be dependent of the number 10. Fuck. Fuck. But this is a sort of thing. That's actually one of the things about doing your own serialization, right? You only have to think about those type of things when you are doing your own thing. Because if you're not doing your own thing, someone else solved that problem for you. They have a format, probably without ambiguity and all of that, and that's cool and all. But you don't get this sort of intuition of like, wait, there is a number 10, man. There is a number 10 for sure. How the heck we modified the data? How
It's
did we?
because it's because
Ah,
we are serializing the size as a single byte straight up. So it's literally the same problem we had to solve for the that we solved by using exploiting abusing UTF-8.
I don't understand that. Um,
It's because the
oh, it's because I increased the amount of characters allowed. Which, by
yes,
the way, what the fuck is this thing?
that thing.
Visual is 2, and then instead of a U, we have that. What in the balls is that?
Uh, I don't know. Let's
How,
see.
how, how does that work? Do we have the tables? Yes, we do. What the? Wait. Which thing? What is this? Is this being read from the disk? So we write the schema, we read the schema, we check, so this is after that's this true. We print the schema, which is this hash table there. We write the rows, so row 1 and row 2. That makes sense. Then we read it and then we print it. So this is right, but in the bytes there is a combination of bits that generates a curly brace. What the
How
fuck?
fun is that?
Uh, uh, I think I'm gonna commit this because we changed the schema essentially, so it makes sense.
Oh, I figure out what happened there. You see the age is 123?
Yeah,
That's a curly brace in ASCII.
but I don't think that has anything to do with. You said the age. Oh, this explains this D as well. Okay, you're right. Uh, so
Oh,
fixed.
that means we cannot store tags in our database.
No, we can store them, I think. Uh,
Can we? Can we really? That worries me, man.
that's understandable. Uh, can we store tens? It really depends how the heck I am reading the data. I have no idea how I
I
am doing
mean,
that.
I mean, if the data is stored um with like length-based chunking instead of using new lines, it shouldn't be a problem.
No, but
And we have no
that's
reason.
how the big boys do it. That's why we didn't do that. How do I read the data? I really don't think that's gonna be a problem. You know why? Because I think I use the schema as the sizing. I don't read the data from the file.
It's
Like
only the schema that has variable sized stuff, right?
no no
The
no no
data
no 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 no
itself,
no no no. The schema knows the size of everything. So when I'm
yes.
reading data, I don't have to put the size in there. Because to read the data, you need to have a schema. So the data is not independent. You cannot read it only with itself. You need to have a schema. So that's why the function read table values from disk actually asks for the schema and asks which table do you want to read that is contained in the schema. Um, so yeah. So I don't think that's going to be a problem precisely because I don't use the size information in the file. I use the size
No,
information contained in the schema.
no, but that's not really what I meant. What I meant is we're not using new lines to separate the rows or whatever in the actual data, right?
No, we are not.
So it should be okay. It should be okay.
So, okay, so 3 hours and a half. So what's the lesson, folks? The lesson is when doing your own
Do not
serialization.
use do
Yes.
not use the number 10.
No, that's not it. But that works. Do not use the scapegoat of separating things by new lines, because if you depend on that later and your interpretation of the data involves characters, then you're fucked because new lines will appear dynamically in a way that you don't know they will be there, and then the separation of your new lines will break, which means breaking whatever the format you establish, and then you are done. So what should you do? You should not depend on new lines, and you should actually,
Instead, you should prefix your data with its
yeah,
length. That's
yeah, you should
the
prefix the
sanest
data
way of
with the
doing
length,
it.
which I didn't do because when I was making the initial serialization of this, it was like 5 a.m. in the morning, and I wanted to get the shortest path possible. And of course, I couldn't foresee how much trouble at 5 a.m. that would cause. I
Hey,
nailed the
Lemos,
first one.
I have a relevant blog article for you. It's written by this dude called Lemus about the cost of refactoring and paying that cost
Yes,
twice.
that's what I wrote about it. But that's the thing. Uh, it is actually, Marinho. Now that you brought that up, it is exactly what happened in what I wrote. But the problem is that I misjudged initially the cost because I already knew this would happen anyway. Like I told you guys, we're gonna make that at some point, and from now, for me, the cost is still worth it because we can proceed, do progress on the project because we are not bottlenecked by having a proper serialization method. This task here added a new cost, like it's almost like a inverse of a promotion. So it got more expensive, which now that I think about it, now the reevaluation tells me that I should address this now, because now we are getting into more deep, complicated serialization, because we are literally writing Racket to the disk, which means that from now
And
on, every single thing that I prefer to do instead of like postponing the refactoring, the curve of the cost is probably going to be exponential instead of linear. So I should not postpone this anymore. I should implement this right away. The problem is that serialization is really boring. That's the problem. Because you have to do the
but
math.
UTF-8 is but UTF-8 is so fun.
It's so fun.
And by the
Ah.
way, my recommendation is to use UTF-8 as your variable length integer encoding of choice because we are already using it in some places and there's nothing wrong with it. So you can use that as your length prefix instead of using new lines to separate stuff, and then the problem goes away.
No, for sure. We definitely should tackle this. I don't know about next Friday because, well, next Friday I will not be here, I guess. So, well, would I be here? Let me check the calendar. So, what's next Friday? Next Friday is 8, and my vacation is set to. Oh, I can't. I will not be here. Okay, so ideally, someone should start working on that. Feel free, Marin, to work on it.
I can do that, I guess.
Ah, okay, I'm gonna finish the recording now.
Bye.